This question belongs to Aptitude subject and was asked in GATE CSE 2015 Set 1. So the question states, didn't you buy dash when you went for shopping? So options are any paper, much paper, no paper or a few paper. Here see, this sentence is a negative sentence. It is a negative sentence. Why? Because here it is saying didn't you buy. So didn't is a negative word. So here any is always used for negative sentences. For a negative sentence, any used. Either it can be used for a countable noun or an uncountable noun. Noun. Like countable noun can be how aren't there any books? So this is a negative sentence and here books is a countable noun. And an uncountable noun can be isn't there any paper. Here paper is an uncountable noun and this is a negative sentence, thus we have used any. So answer is option A. This question belongs to GATE CSE 2015 Set 1 and the subject name is Aptitude. So the question states, which one of the following combinations is incorrect? So first we have acquiescence and submission. So what is the meaning of acquiescence? Acquiescence means to accept without any protest. So if we are accepting something without any protest, then it is called acquiescence. And submission has the same meaning. So it is a correct relationship. Then what is the meaning of wheedle? Wheedle means if we are using flattery to get something. And wheedle means using flattery to get something. And what is the meaning of roundabout? Roundabout is basically taking a indirect longer route instead of a shorter one, which means if we are taking a longer route, then this is called a roundabout. So wheedle and flattery, wheedle and roundabout do not have any relationship. So this combination is incorrect. So let us see option C, flippancy. So what is meaning of flippancy? Flippancy means lightness or do not or being ignorant, not showing any seriousness. So flippancy and lightness has the same meaning. So its combination is correct. What is the meaning of profligate? Profligate means excessive or wasteful, and it has the same meaning as extravagant. So it also represents the same relationship. So the combination that is incorrect is option B, wheedle and roundabout. This question belongs to Aptitude subject and was asked in GATE CSE 2015 Set 1. So the question states, given set A equals to 2, 3, 4, 5. So set A has 2, 3, 4 and 5. And set B has 11, 12, 13, 14 and 15. Two numbers are randomly selected. So one is taken from set A and one is taken from set B, N1 and N2. What is the probability that the sum of two numbers equals to 16? So we have to find N1 and N2 such that their sum is 16. So what all possible options are there? 2 can map with 14 as 2 plus 14 is 16. 3 can map with 13 as 3 plus 13 is 16. 4 can map with 12 and 5 can map with 11 as both of them also sum to 16. So number of possible combinations are 14 which satisfy a condition of sum equals to 16. And what is the total number of outcomes? 2 can map with any item of B, 3 can map with any item of B, same with 4 and 5. So total possibility equals to cardinality of A into cardinality of B, which is 4 into 5, which is 20. And favorable is 4. So the probability is 4 by 20. Probability of event is 4 by 20, which is equals to 0.2. So answer is 0.2. This question belongs to Aptitude subject and was asked in GATE CSE 2015 Set 1. So the question states, which of the following options is the closest in meaning of the sentence below? So the sentence is, she enjoyed herself immensely at the party. So what is the meaning of immensely? Immensely is a positive term, which means to its fullest, which means she had a good time at a party. Good time at the party. Now let us see the options. So options is referring just in these words: terrible, horrible, terrific and terrifying. So we have to tell which is the synonym for having, for immensely or having a good time. So terrible means a bad time, horrible means a bad time, terrifying means a frightening time or a bad time, signifying a bad time only. But this, she had a terrific time at a party, signifies that she had a good time at a party. So answer is option C. This question belongs to aptitude subject and was asked in GATE CSE 2015 Set 1. So the question states, based on the given statement, select the most appropriate option to solve the following question. If two floors in a certain building are 9 feet apart, so we have a building such that if we have first floor and a second floor, suppose there is a 3-floor building. Then if we want to go from this floor to this floor, then the distance between them is 9 feet. How many steps are there in set of stairs that extend from first floor to the second floor of the building? Statements. Each step is 3 by 4 feet high. Each step is 1 foot wide. Then it is asking statement 1 is alone sufficient, but statement 2 alone is not sufficient. Okay, let us see about statement 1. If we have been given height of each foot, then we know if we have to reach from here till here, and we know that this step is this much height, this step is this much height, this step is this much height, then we can find number of steps required. How? 9 divided by 3 by 4, which is equals to 36 by 3, or 12 steps are required. Because 12 steps, each with height 3 by 4, will give us 9 feet, 9 foot. Thus, using 1 we can find out. 1 alone can find out. Now suppose we are given the width of each foot. So width means this one. We are given 1 feet. So can we calculate? No, we can't calculate. As we do not know how far are they. We just know their height. We do not know their distance. And even 2 floors can be one above another. So it is not alone sufficient. So answer is statement 1 is alone is sufficient, but statement 2 alone is not sufficient. Option A is correct. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, the pie chart shown below has the breakup of number of students from different departments in an engineering college for the year 2012. So for the year 2012, this shows how many percent of students are in various departments. The proportion of male to female students in each department is 5 by 4. So the ratio of number of males to number of females in all the department is 5 by 4. Okay. There are 40 males in electrical engineering. What is the difference between number of female students in civil? So we have to find number of, let it be noted by N, females in civil, NFCL, civil, and the female students in mechanical, which is number of female in mechanical. We need to find what is the value of this, the magnitude of this. So let us see. If we know that the number of students in electrical is 40 males in electrical. Okay, so males in electrical double E equals to 40. So we know male to female ratio is 5 by 4. So if we have males are 5x, then females are 4x. Or we can also find female by female equals to, by doing multiplication, cross multiplication, we will get 4 by 5 into number of males. So what are the females in electrical? Females in double E equals to 4 by 5 into number of males, which is 40. So 5, 8, 40. So we got 32 females in electrical. So total strength of electrical, total double E strength, it's equal to male plus female, which is 72. Now see, this electrical comprises of 20% of the total strength. So if we know that 20% of the total strength, which means if total strength is, let us suppose Y, then 20% of Y is 72. And what is the value of Y? Y equals to 72 into 100 by 20, which is equals to 72 into 5, which is equals to 5 into 10, 535 plus 1, 36, which is we have total 360 students in the entire college. So let us see how we can do it now. So we got number of students in the entire college. Okay, now see, if we know the number of students in entire college, then we need to find number of females in the civil department. Okay, so students in civil total strength, civil strength will be civil comprise of 30% of 360, which is equals to 36 into 3, which is equals to 108. Now females in civil, females. So if we can say male plus female equals to total strength. So his male is 5x and female is 4x, which means total strength is 9x. And what are the female? Female are 4x out of 9x. So it is 4 by 9 of the total strength. So what are the number of females? Females are 4 by 9 of total strength. Total strength is 108, or we can write 36 into 3. So we have 3 into 3, 9, 12. We have 48 females in civil. Now let us do the same calculation for the second department, which is mechanical. So to mechanical strength, what is mechanical strength? Mechanical comprise of 10% of 360. So it's 10 by 100 into 360. So we get it to be 36. So females in mechanical equals to 4 by 9 of the mechanical strength, which is equals to 16. So what we need to find? We need to find, let me not clear this. Yeah. So what we need to find? We need to find difference between the male and female in civil and mechanical. So what are the number of females in civil? They are 48. What are the number of females in mechanical? They are 16. So 48 minus 16 modulus is 32. So answer is option A, 32. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, select the correct alternative meaning of the underlying part of the sentence. The chain snatchers took to their heels when the police party arrived. So what is the meaning of this? The meaning of this is there were some chain snatchers and took to the heels means, which means they ran away. So when the police arrived, they ran away. So let us see the options. So we need to find the synonym of the sentence ran away. So first is took shelter in a thick jungle. No, this is false. Open indiscriminate fire. No, this is also false. Took to flight. Yes. This also has the same meaning as to run away or to flee. To flee, to run away, or to took to their heels, or took to flight, all have the same meaning. Unconditionally surrender. No, this is also false. So answer is option C, took to flight, means to run away. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, the probabilities that a student passes in mathematics, physics and chemistry are M, P and C respectively. Of these subjects, the student has 75% chance of passing in at least one. So for P, N denotes the number of subjects in which the student pass. So for at least one, the probability is 75% or 0.75. A 50% chance of passing in at least two. So for P, N greater than equal to 2, the probability is 0.5. And a 40% chance of passing in exactly 2. So for P, N equals to 2, probability is 0.4 or 40%. Following relations are drawn in MPC. P plus M plus C equals to 27 by 10, P plus M plus C equals to 13 by 20, and P into M into C equals to 1 by 10. So we need to tell which all are true. So we just need to find P plus M plus C and P into M into C. Okay. Let us see how we can do this. Okay. So we have been given P, N is greater than equal to 1. So probability for N equals to 0, which means the student passes in no subject, equals to 1 minus probability that it passes in at least one subject. So probability of passing in no subject, probability of no pass equals to 1 minus p n is greater than equal to 1. So it passes in none of the subject, which means in maths it fails 1 minus m, as it passes in maths with m, so it fails with 1 minus m. Passes in physics with p, so fails with 1 minus p, and it fails in chemistry by 1 minus c, equals to 1 minus 0.75. If we expand this, we will get 1 minus p minus m plus mp into 1 minus c equals to 0.25. So we have 1 minus p minus m plus mp. Okay. Now again expanding this, we get 1 minus c minus p plus pc minus m plus mc plus mp minus mpc equals to 0.25. Now again we can try to modify this and get, let me clear all this stuff out so as to manage some space. Yeah, so if we send all of these to the right hand side and 0.25 to the left hand side, we get 0.75 equals to m plus p plus c minus mc minus mp minus pc plus mpc. Okay, let us assume this is equation 1. Now we are given probability of exactly 2 passes. It's 0.4. So 0.4 is exactly 2 passes. So exactly 2 means it passes in maths and physics and fails in chemistry. It means fails in chemistry, or it can fail in or fails in maths or fails in physics, because if it passes in exactly 2, it will fail in exactly 1. So zero point 0.4 equals to, if it fails in chemistry, then it passes in maths and physics and fails in chemistry. Okay, fails in maths, which means 1 minus m, passes in physics and passes in chemistry. Fails in physics, which means passes in maths, fails in physics and passes in chemistry. So we get 0.4 equals to mp minus mpc plus pc minus mpc plus mc minus mpc. So we get 0.4 equals to mp plus pc plus mc minus 3 mpc. Okay, so mp plus pc plus mc minus 3 mpc. Yes, so this we got as the second equation. Now let us see if we can derive anything else from this. Okay, so we have used this equation and this equation. We are left with this equation. Let us see if we can do anything with this. What is the meaning of Pn greater than equal to 2? If we say someone passes in more than 2 subjects, then it can comprise of, it can pass in exactly 2 subjects and it can pass in all the 3 subjects. Okay, what is the probability of at least 2? It's 0.5 given. What is the probability of exactly 2? It's 0.4 given. So what is the probability of passing in all the 3? It is MPC. So we get MPC equals to 0.5 minus 0.4, it's 0.1. So it is equation 3 and this is equation 2. Now let us solve it further. Okay, so we have got MPC and we needed MPC. So MPC is 0.1, or we can write 1 by 10. So this one is correct. Option 3 is correct. Now let us see what is the value of m plus p plus c. Okay, so let us add equation 1 and 2. So adding 1 and 2, we will get 0.75 plus 0.4, it's 1.35. It's no, wait, 0.75 plus 0.4 is 1.15. So we get 1.15 equals to m plus p plus c, mc cancels mc, mp cancels mp, pc cancels pc, and we get -2 mpc. And what is the value of mpc? It's 0.1. So we get 1.15 equals to m plus p plus c minus 2 into 0.1, which is 0.2. So we get m plus p plus c equals to 1.15 plus 0.2, it's 1.35. We can write it as 135 by 100. So if we divide it by 5, we will get 20 over here, and we will get 5 to the 10, 5, we will get 27 over here. So m plus p plus c is 27 by 20. So option 1 is also correct. So 1 and 3 are correct. So answer is option D. Relations 1 and 3 are true. This question belongs to Aptitude subject and was asked in GATE CSE 2015. So the question states, the given statement is followed by some courses of action. So we have a statement followed by courses of action. Assuming that the statement to be true, decide the correct option. So the statement is, there has been a significant water drop in the water level in the lakes supplying water to the city. Okay, so there are some lakes supplying water to the city, and there is a drop in the water level in those lakes. So the course of action are, the water supply authority must impose a partial cut in supply to tackle the situation. Can we do this? Yes. As it is a partial cut, yes, we can do the partial cut. Like we can reduce the water supply by some amount so that lakes can replenish again, and we can then give proper supply to the city. The government should appeal all the residents through mass media for minimal usage of water. Yes, as if the citizens will use less water, then automatically the consumption will reduce and lakes will replenish. The government should ban the water supply in lower areas. No, this is a very strict option, like banning the water supply in an entire area. Water is a necessity, so we can't ban this water in an entire area. So answer is option 1 and 2. So option A is correct. Statement 1 and 2 follow. This question belongs to Aptitude subject and was asked in GATE CSE 2015. So the question states, the number of students in a class who have answered correctly, wrongly, or not attempted each question in an exam are listed in the table below. The marks for each question are also listed. So there was an exam conducted which has 5 questions. Question 1 was for 2 marks, 2 was for 3 marks, 3 was for 1 marks, question 4 was for 2 marks, and question 5 was for 5 marks. Now, out of the total strength, so what is the total strength? You can sum up any of the row and you will get total strength. So it's 21 plus 17 plus 6. So it's equals to 21 plus 17 plus 6. It's 44. So 44 is the total strength. You can sum up any of the row. Like 31 plus 12 is 43 plus 1 is 44. So out of 44 students, 21 answered correctly the first question, 17 of them answered it wrong, and 6 didn't attempt it. There is no negative or partial marking. Now we have to tell what is the average of the marks obtained by the class in the examination. Okay, so what will be the average? So average will be equals to, for the first question, how many marks did the entire class obtain? 21 students answered it correctly and they got 2 marks. And 17 got 0 marks and 6 got 0 marks, so there is no point of adding it. 15 students got 3 marks for the second question, 11 students got 1 mark for the third question, 23 students got 2 marks for the fourth question, and 31 students got 5 marks for the fifth question. What are the total number of students? They are 44. So average marks equals to 21 into 2, 44, plus 15 into 3, 45, 11, plus 46, plus 155 by 44. So it's equal to 299 divided by 44. So if you do it, you will get 6.795. So answer is option C. This question belongs to compiler design subject and was asked in GATE CSE 2015. So the question states, which one of the following is true at any valid state in a shift reduced parsing? Viable prefixes appear only at the bottom of the stack and not inside. Viable prefixes appear only on the top of the stack and not inside. The stack contains only a set of viable prefixes. The stack never contains viable prefixes. So let me tell you the concept of viable prefixes. So for knowing a viable prefix, first let me tell you a definition. Viable prefix is nothing, it is just the prefix of rightmost derivation which extend up to the handle. So for knowing viable prefix, you must know what is a handle. Now let me explain you what is a handle. Suppose we have a grammar like S implies XX, then X implies AX or B. And now let us try to derive the string AA. So how we will do this? We will start with S, then we will do S implies XX. So see, what is being reduced from XS? XX is being reduced. Okay. Now what we will do? We are doing rightmost derivation. So this X will be replaced by B. So we will have XB. So what was being reduced? What will be reduced if we are going back? This will be done. Okay. Now X will be replaced by AX. So X will be replaced by AX and we will have B. Okay. So what we are doing? We can go it back by replacing X by AX. Okay. Now we have X can again be replaced by AX. AX and B, which means this AX. Now this X will be replaced by B. So we will have AA. So how can we go back? We can go back by replacing B by AX, B by X, AX by X, AX by X, B by X and XX by S. So all these underlying things are handles. And what are the prefixes of handles? So this will have prefix X, XX or null. This will have prefix X is already present. See, this will have prefix X and XB. This will have prefix A and AX. This will have prefix. The prefix will be taken from starting up till the handle. A, AA, AAX. This will have prefix A, AA, AAB. Now, what is a viable prefix? Viable prefix is nothing but it is a prefix of rightmost derivation which extend up to the handle. So let's combine all of them. You will get X, XX, XB, A, AX, AA, AAX and AAB. All of them are viable prefixes. Now see, viable prefix appear only at the bottom of the stack. No, we can have viable prefix in the mid also. Okay, viable prefix appear only on the top of the stack. No, actually our string can be represented as a combination of viable prefix. We will have viable prefix 1, viable prefix 2, viable prefix 3. It can, at any step we can write it as a combination of viable prefixes. Okay, see here, X is a viable prefix, B is a viable prefix. See here, AX is a viable prefix, B is a viable prefix. Here A is a viable prefix, AX is a viable prefix and B is a viable prefix. A is a viable, AA is a viable prefix, B is a viable prefix, B is a viable prefix. So it can be written as a combination of viable prefixes. Stack never contains viable prefixes? No. As all these contents are in stack, so stack does has viable prefixes. Answer is option C. This question belongs to software engineering subject and was asked in GATE CSE 2015. So the question states, match the following. We have condition coverage, equivalence class partitioning, volume testing, alpha testing, and we need to match it to black box testing, system testing, white box testing and performance testing. So it's basically related to the type of testing. You can refer to the following material for this. So what is a white box testing? So in white box testing, we are also testing the internals of any application. And in black box testing, we just consider it as a black box and do not test the internals, just which verify the input with the output. So see, white box testing tests internal structures of working of an application. It covers the following: control flow testing, data flow testing, branch testing, statement coverage, decision coverage, modified conditional decision coverage, prime part testing, part testing. So conditional coverage must be a white box testing. So conditional coverage is a white box testing. So it's mapped to option 3. Now, what is an equivalence class partitioning? It's basically a type of black box testing. So black box testing is a method of software testing that examines the functionality of an application without peering into its internal structure of working. So here we do not test the internal working, we just verify the input with the output. Typical black box test design techniques include decision table testing, all pair testing, equivalence partitioning, boundary value analysis, cost effect graph, and error guessing. So equivalence class partitioning is a type of black box testing. So answer is option 1. Volume testing is a performance testing for a specific size. So volume testing is mapped to option 4. Now alpha testing. Alpha testing is basically a system testing by potential customer or user on an independent test team at developer side. So alpha testing is mapped to option 2. So answer is 3142. Option C is true. This question belongs to computer organization subject and was asked in GATE CSE 2015. So the question states, for computers based on 3 address instruction format, each address field can be used to specify which one of the following: a memory operand, a processor register, or an implied accumulator register. So what is a 3 address instruction format? 3 address instruction format is basically an intermediate code format in which each instruction can have at max 3 addresses. At max 3 addresses. Now these address can either be a memory operand, or they can be a processor register. Now these processor register are also of different types like stack pointer, program counter, accumulator, or general purpose registers like R1, R2, R3. Now let us see the options. They can be used to specify a memory operand, yes. A processor register, yes. An implied accumulator register. An accumulator register is also a type of processor register. Here see, accumulator is a type of processor register. So all 3 are true. Answer is option D. I will give you an example. Let us suppose we had x equals to a plus b into c plus a, and we need to write the 3 address code for it. So how we will write it? We will first do at r1 a comma b. So then we will do add r2 c comma d. Then we will do multiply x r1 r2. So let me explain these to you. So this is the first operand, second operand, and this is a result. So here we are going to memory location A, adding it with the content in memory location B, and storing it in register R1. So see here, R1 is a process register and A is a memory operand, B is a memory operand. Now in R2 general purpose register, we are storing the contents at memory location C plus memory location D. Similarly, we are multiplying 2 general purpose registers and storing the value at memory location represented by X. So these are example of all these being used, and we can also perform some operation with the accumulator, like we can do add. If we do add X, then what it will do? It will store in the accumulator the value which is present in the accumulator plus the value which is present in memory location X. So this is the example of accumulator being used as an address. So here accumulator is implied, it's implicit, and we are providing it over here. Or we can also do add the value of accumulator. We can do it like this: store in R1 the value which store in R2 the value which is present in R1 as well as accumulator. So it will store the add the value of accumulator and R1 and store it in R2. Okay, so answer is option D. This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, which one of the following is the recurrence relation for the worst case complexity of quicksort? So for quicksort, in case of worst case complexity, we need to find what is the recurrence relation. For sorting, n is greater than or equal to two numbers. If the recurrence in the recurrence equations given in the option C is a constant. Okay. So what is the process of quicksort? So in quicksort, we first find a pivot. We find a pivot and then we partition and solve recursively for left and right partition. So what is the best case? Suppose we have n numbers, n1, n2, n3 up to nn. In best case, during partitioning, half of them will come to the right, half of them will come to the left. So n by 2 over here, n by 2 over here. So in best case, complexity is Tn equals to n for partitioning and 2t n by 2 for solving it recursively. This is the best case. But what happens in the worst cases? Suppose worst case happens in three cases. I will give you an example. So worst case happens when the array is sorted in ascending order, the array is sorted in descending order, or all the items are same, all elements same. Let us take an example of sorted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let us assume first item is taken as pivot. So all the items less than pivot should come on its left and all the items greater than pivot should come on its right. So nothing comes on the left and all n minus 1 items come on the right, which means 2, 3, 4 up to 10. Then again 2 is taken as pivot, nothing comes on the left and n minus 1 items come on the right. So complexity is Tn equals to, with n for applying partition, nothing comes on the left and n minus 1 items come on the right. So this is the complexity for worst case. T1 or T0, anything you can write. So answer is option B. What happens in descending sorting? So if these items are sorted in descending order, let us suppose 10, 9, 8, 7, 6, 5, 4, 3. Then 10 is taken as pivot. Everything on the left is the items less than 10. So everything comes on the left, which is 3, 4, 5, 6, 7, 8, 9, and nothing goes on the right. Then again, anything is taken as pivot. Let us suppose 9 is taken as pivot. Anything can occur as a pivot. Then n minus 1 items come on the left and nothing on the goes on the right. So complexity is same. Tn equals to Tn minus 1 for recursive call and order of n for applying the partitioning algo. And same when all the items are same, like 7, 7, 7, 7, 7, 7. 7 is taken as pivot, or nothing comes on the left and all the items comes on the right. And same goes on. So answer is option B. This question belongs to theory of computation subject and was asked in GATE CSE 2015. So the question states, for any two languages L1 and L2 such that L1 is context-free language CFL and L2 is recursively enumerable, which is RE language, but not recursive, RE but not REC. Which of the following are necessarily true? L1 complement is recursive, L2 complement is recursive, L1 complement is context-free, L1 complement union L2 is recursively enumerable. Okay. So first, remember this, that Venn diagram goes something like this. Initially we have regular language, then we have DCFL, then we have CFL, context-free language, then we have CSL, context-sensitive language, then we have recursive language, then we have recursively enumerable language, then we have non-recursively enumerable languages. And all lower languages are also upper language, which means every DCFL is a CFL, every DCFL is a CSL, also a REC, also a RE. And a CSL may or may not be a CFL, may or may not be a DCFL, may or may not be a regular language, but is always a REC and always a RE, which means anything below is always anything upper, and here down is there is no surety, it may or may not be. Now let I have already told you to remember this table. It is very helpful in answering these type of questions. Now let us see. Just remember these tables and here are those operations. Yes means, see, we map the rows and columns. So for regular language, union of two regular languages is always regular. Thus yes. A DCFL, the union of two DCFL may or may not be a DCFL. Thus no. Yes means always. Always valid. No means may or may not be valid. Okay. Now let us see. Option 1 is L1 complement is recursive. What is L1? L1 is context free. Let us see context free complement. Context free complement, it's not defined. It may or may not be a context free. But see, L1 is context free. If it is context free, it is also CSL. Now let us see CSL. CSL complement is a CSL. Okay. And it is asking for recursive. Okay. Can we say L1 is a CFL? Thus it is also a CSL and also a REC, which means L1 is a REC. What is REC complement? REC complement is REC, which means L1 complement is REC. Option 1 is true. L2 complement is REC. What is L2? L2 is REC but not RE, which means it is only REC but we can't go above. Okay. So what is REC complement? Sorry. What is L2? L2 is RE but not REC. So L2 is RE but not REC. Okay, which means we can't come down. So what is RE complement? It may or may not be RE. So it may or may not be REC. So thus L2 complement is recursive is false. L1 complement is context free. What is L1? L1 is context free. Context free complement. It may or may not be context free. Thus we can't be sure. L1 complement union L2 is RE. Okay. What is L1? L1 is CFL. CFL is also a RE? Yes. CFL is also a REC? Yes. So see, L1 is a CFL. Okay. CFL is also a RE. So L1 is also a REC. It is also REC, also a CSL, everything it is. So L1 is also a REC. So what is L1 complement? L1 complement is REC complement. What is REC complement? It's REC. So L1 complement is REC. Now L1 complement union L2. What is L1 complement? It's REC union. What is L2? L2 is RE. Now see, every REC is also RE. So we get RE union RE. What is union of two RE languages is always a RE language. Thus L1 complement union L2 is RE. So option 1 and 4 are true. So answer is option D, 1 and 4 only. This question belongs to computer network subject and was asked in GATE CSE 2015. So the question states, suppose two hosts use a TCP connection to transfer a large file. Which one of the following options is are false with respect to TCP connection? So let us see all of them one by one. Option 1. If the sequence number of a segment is M. So in a segment we have a sequence number field if it is M. The sequence number of the subsequent segment is always M plus 1. No, it is false, as it depends on the number of 8-byte characters. As 8-byte character, for each 8-byte character we are increasing one sequence number. So it depends on the number of 8-byte characters that are present. It might be present that it may increase by some M plus X amount. So this is false. Second option. If the estimated rounded time at a given point of time is t second. Rounded time means the time in which a packet comes back. So if it is t seconds for the entire trip, the value of retransmission timeout is always set to greater than or equal to t second. What is retransmission timeout? Retransmission timeout is basically used if we do not get a packet within a given amount of time, then we need to retransmit it as we assume that it is lost. So we definitely need to set the retransmission timeout greater than equal to t, as only then there is a possibility that the packet will come back, because assume that the packet is coming back in 10 seconds and retransmission timeout is set to a value 8, which is less than 10. Then we send a packet and it is expected to come. We sent a packet at 0 and it is expected to come at 10. But retransmission timeout is only 8. So after 8 seconds, without waiting for the packet, we are again transmitting the packet. And again, the packet will come at 8 plus 10, 18 seconds, but we are again retransmitting after 8 seconds at 16 seconds. So it will lead to an infinite loop. The retransmission timer should always be greater than equal to round trip time. So this is, then the value of retransmission timeout is set to this. This is true. Okay. The size of advertised window never changes during the course of TCP connection. Okay, this is a false statement. Why? Because the size of receiver's window do not change during the course of TCP connection, but the size of sender window keeps on changing based on the processing capability of the receiver. So this is false. The size of receiver window do not change, but the advertised window keeps on changing based on the processing capability of the receiver. The number of unacknowledged bytes at the sender is always less than equal to the advertised window. Yes, unacknowledged bytes should always be less than equal to the advertised window, because advertised window shows how many bytes are left acknowledged and how many are sent. So they need to be accommodated in a frame. Thus, unacknowledged bytes should always be less than equal to advertised window. Thus, this is true. When to tell which all are false. So false is option 1 and option 3. So option B is true, 1 and 3 only are false. This question belongs to operating system subject and was asked in GATE CSE 2015. So the question states, the following two functions P1 and P2 that share a variable B with the initial value of 2. So we have B with a value of 2. Execute concurrently. So P1 and P2 execute concurrently. The number of distinct values that B can possibly take after the execution is. Okay. So we need to tell how many values for B are possible. Let us name these statements are P1A, P1B, P2A and P2B. Suppose first we are doing P1A followed by P1B, then P2A, then P2B. Then we do P1A. So what is the value of C? C will hold B minus 1, which is 1. Then B will hold 2 into C, which is 2. Okay. Then we need to tell the entire value after the execution, not the intermediate values. Now D will hold 2 into B. D equals to 2 into B, which is 2 into 2, which is 4. B will hold D minus 1, which is 4 minus 1, which is 3. So B holded a value 2, now a value 3. Okay. Now let us suppose we do P2A, P2B, P1A, P1B. So what will be the values that each of them will be holding? So B had a value 2. We will always start with a value 2. We had a value 2 and a value 3. Okay. So first P2A, D will hold 2 into B. D will hold 4. B will hold D minus 1, which is 3. C will hold B minus 1, which is 2. B will hold 2 into C, which is 4. So a new value 4 is present. Now let us see if any other sequence is possible. Yes, we can have P1A, then P2B, then P2A, then we can have P1B, then P2B. Okay, B has a value 2. P1A, so C will hold B minus 1, which is 1. P2A, D will hold 2 into B, which is 4. P1B, so B will hold 2 into C, which is 2. So B will be updated to 2. Now B will hold D minus 1, which is 3. B will be updated to 3. No new value is invented. Let us see if any other sequence is possible. We can have P2A, P1A, P2B, P1B. Sorry. So B had a value 2. So P2A, D will hold value 2 into B, which is 4. P1A, C will hold value B minus 1, which is 1. P2B, B will hold D minus 1, which is 3. Now P1B, B will hold 2 into C, which is 2. Okay, 2 is present. And we can have more things like P2A, P1A, P1B, P2B. But you will get to know that only these three values are possible. So the distinct values are 3, 2, 3 and 4. Cardinality of distinct values is 3. So answer is 3. This question belongs to Digital Logic Design subject and was asked in GATE CSE 2015. So the question states, consider a 4-bit Johnson counter with an initial value 0000. The counting sequence of this counter is. So what is a Johnson counter? Johnson counter is nothing but it is a switch tail ring counter. So I will show you the diagram how it is made. So Johnson counter is basically made with D flip-flops. So we have 4 D flip-flops, and in this the output of the last flip-flop, the complemented output, which is Q4 complement, is basically connected to the input of the first flip-flop, and it is a synchronous counter as we have the same clock pulse in all. So now let us see what will be the output. So we have Q1, Q2, Q3, Q4. What is the initial value? It is given as 0000. So what is the next state of Q flip-flop? So Q1 plus equals to D, D1, Q2 plus equals to D2, Q3 plus equals to D3, Q4 plus equals to D4. Okay, so what happens? So D1 is nothing but Q4 complement. D1 is nothing but Q4 complement. Q4 complement. What is D2? D2 is nothing but Q1. What is D3? D3 is nothing but Q2. What is D4? D4 is nothing but Q3. Okay. So what will be the next step? Let us write it over here. It will be Q4 complement. It will be Q1. It will be Q2. And it will be Q3. Okay. So what is Q4 complement? 0 complement 1. Here we will have 3 zeros. Now we will have 0 complement 1 will come over here, and all of, so it's basically shifting all of them right, and first one is the complement of the last one. So 1 0 0. Now again shifting both of them right, all of them right, and 0 complement is 1. Again shifting all 3 of them right, 0 complement is 1. Okay. Again shifting all 3 of them right, 1 complement is 0. Again shifting them right, 1 complement is 0. Again shifting them right, 1 complement is 0. Again shifting them right, 1 complement is 0. So we will get 0 0 0 0, which is nothing but our first state. So after this we go to this. So how we go? So let us write the equivalent values. This is 0, this is 8, this is 12, this is 14, this is 15, this is 7, this is 3, 1, and then again 0. So answer is option D, 0, 8, 12, 14. So it goes in this sequence: 0, 8, 12, 14, 15, 7, 3, 1 and 0. Then again 0, 8, 12, 14. So answer is option D. This question belongs to computer network subject and was asked in GATE CSE 2015. So the question states, which one of the following fields of an IP header is not modified by a typical IP router? So suppose we have options: checksum, source address, time to live and length. Suppose we have a frame coming over here with the IP header and data. Now here comes a router. So what can happen? Suppose this link has a different MTU and this had a different maximal transmittable unit. Then we need to do fragmentation. In fragmentation, this datagram breaks down into various others IP datagrams. Okay, so here if suppose total length was 1000, so total length will get reduced over here. So total length can be changed. It can be changed. Now what is time to live? So time to live is nothing but it is a field assigned in a IP header. If suppose it is 5, so it is used to prevent infinite loops. Suppose we have a link like this. We get a packet over here. This router forwards it to this forwards it to this, and this forwards it to this. Then it will fall in infinite loop and cause congestion in the network. To solve this congestion, we have a TTL value, time to live. So if we have TTL 5, then in each hop TTL is decremented. Then at here TTL become 4, here TTL become 3, then it becomes 2, then 1, and then it becomes 0. If TTL is less than 1, then the packet is discarded to avoid congestion. And we are changing TTL at each hop. Thus, and TTL is present in this IP header. Thus, TTL value gets changed. Checksum. Checksum is calculated for the IP header. As TTL value is changing, this checksum is also changing. Yes. Source address. Source address is generally not changed by any intermediate router. So, which is not modified? Answer is source address. Option B. This question belongs to Database Management System subject and was asked in GATE CSE 2015. So the question states, select operation in SQL is equivalent to selection operation in relational algebra, selection operation in relational algebra except that select in SQL retains duplicates, projection operation in relational algebra, projection operation in relational algebra except that select in SQL retains duplicates. Okay. So let me explain you with the help of an example. Suppose we have a table name student and it contains student data like student name, student roll number and student age and marks. Okay, marks in a particular subject. Let us populate the entries. Suppose we have a student named A, roll number 1, age is 17 and marks he got is 20. A student B, roll number 2, age is 15, marks he got is 17. Student B, roll number 3, age is 17, marks he got is 19. Let us suppose another student with marks 20, age 17, roll number 4 and the student D. Okay. Now suppose we want to get age of students who got 20 marks, who got greater than equal to 20 marks. So how we will write the SQL query for this? So SQL query will look something like this. Select what we need to get. We need to get age from our student relation where marks are greater than equal to 20. Okay, so what will it give? It will give us a age value, marks greater than equal to 20. So we have A and D and the ages are 17. But this one do not remove duplicates. So we will get 17 and 17. If we want to remove duplicates, we must write over here distinct. But by default, it do not remove duplicates. Now what will be the relational algebra equivalent for this? Relational algebra equivalent will look something like this. From the table student, select based on the operation that marks are greater than equal to 20. This is the selection operation. And then we need to project. This is projection. We need to project only age. Okay. Now see the difference between two. Here the verb select is basically specifying based on which entity we need to get in the output. Here the same is specified by projection. So select in SQL and this will give us the output age and 17. It by default gives us the distinct values. Duplicates are removed. So select operation is equivalent to projection operation. It is equivalent to projection operation in relational algebra. Now about duplicates, SQL will have duplicates by default. We need to remove them, but relational algebra won't have duplicates. So except that select in SQL retains the duplicates. So answer is option D. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, in the LU decomposition of the matrix, so matrix M is given, if the diagonal elements of U are both 1, then the lower diagonal entry L22 of L is. Okay. So what is LU decomposition of the matrix? So here we have our matrix 2, 4, 2, 9. We decompose it into product of a lower triangular matrix and an upper triangular matrix. Now what is a lower triangle? This is L lower triangular matrix and this is U upper triangular matrix. What is a lower triangular matrix? A lower triangular matrix has entries only in the diagonal and lower to the diagonal. So it will have L11, L21 and L22. It only has these entries and the above entries are 0. And upper triangular matrix has just upper entries and lower entries are 0. U11, U12, U21 is 0 and we have U22. Okay. So what is given in the question? We are given that the diagonal elements of U are both 1. So we have 2, 4, 2, 9 equals to L11, 0, L21, L22 and these both are 1. So we have 1, 0, 0, U12. Let us do the multiplication. So 2 equals to L11. Then we have L11 into U12 equals to L11 into U12. Sorry, this one is 1. It is given that both the entries are 1. So we have L11 as 2, then L11 into U12 as 4. So putting L11 value we get U12 equals to 2. Okay, now let us do for this row and this column. So we get L21 equals to 2. Then we get L21 equals to, see, for this one we have done, for this one we have done. Now this one equals to this row and this column. So L21 equals to 2. Now 9 equals to L21 into U12 plus L22 equals to 9. So what is L21? It's 2. What is U12? It's 2. 2 to 4. So L22 equals to 9 minus 4, which is 5. So L22, we need to find the lower triangular entry L22 and its value is 5. So answer is option A. This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, match the following. We have Prim's algorithm for minimum spanning tree, Floyd-Warshall algorithm for all pair shortest path, merge sort and Hamiltonian survey. And list B contains backtracking, greedy method, dynamic programming and divide and conquer. Let us see all the options one by one. So what is Prim's? Prim's algo is basically used to find the minimum spanning tree. So what is the minimum spanning tree? Suppose we have a graph like this, 10. Okay, let us take like this A, B, C and D. And it has edges 10 over here, 20 over here, 30 over here, 40 over here and 50 over here. Then what is a spanning tree? Spanning tree is a subgraph of a graph which is a tree. Tree means it should be acyclic and it should be connected. And if the graph has V vertices and E edges, the tree should have all the V vertices and number of edges should be equal to number of vertex minus 1. Okay, so it will have many spanning trees like A, B, C, D. This 50, 40, 10. This is a spanning tree. We can have other spanning trees like A, B, C, D. 10, 30, 50. But if we have cost associated with each spanning tree. Here we have 50 plus 1, 60 plus 40, 100 cost. Here we have 53, 80 plus 1, 90 cost. So minimum spanning tree, in minimum spanning tree we need to find the minimum cost. So for this we have either Prim's algo or Kruskal algo. In Kruskal it is based on finding the minimum edge and combining them. Prim's algo, how Prim's algo works is that we go with any of the vertex. Let us suppose we start with vertex A. And then we find the minimum edge among all its adjacents. So among 10, 30, 40, minimum is 10. So we do 10 and B. Now we find minimum among A and B. So A has 40, 30 and 10 and B has 20. So minimum is 20 for D. Now we find minimum among this A, B and D. So minimum is 30, but it is making a cycle, so we neglect it. Now next minimum is 40. So we have 40 as the next minimum. Now this is our spanning tree. So here we are finding minimum at each step. Thus it is based on greedy method. So PRIMS is based on greedy method. Let us see second option. So second one is Floyd version. Floyd version is basically used to find all pair shortest path. So if we have certain graph like this, then we need to find what is the shortest path to go from A to B, C, D as well as E, like all pairs, and from E to all A, B, D and C. So it's basically based on dynamic programming method. If you want to learn more about this, you can go to this link and you will get to know the DP solution for Floyd version algorithm. Okay, let us see option C. It's merge sort. So how merge sort works? Suppose we have 20, 10, 30, 50, 5, 11, 19. So it's based on divide and conquer. So what it does is that it finds the midpoint 1, 2, 3. So here 50 is the midpoint. Okay, then it divides it into two parts. Here we have 20, 10, 30, 5, 11, 19. Let us suppose 50 comes over here. Again it divides it into two parts till we get a single part. Let us suppose we get here 20, 10, 30, 5, 50, 11, 19. Now it combines it. So here initially it sorts it. It's already sorted. Now while combining, it makes sure that it is sorted. So it combines these two and gets 10, 20, 30. It combines these two and gets 5, 11, 19 and 50. Then it combines these two to get 5, 10, 11, 19, 20, 30, 50. So it's basically based on divide and conquer, DSC based algorithm. So Floyd version was DP, merge sort is divide and conquer. Let us see Hamiltonian circuit. So what is a Hamiltonian circuit? So we have been given a graph. So a Hamiltonian path. Let me first show you the graph. If we have some graph like this, C, D, E, like this. Then a Hamiltonian path is a path that traverses all the vertices exactly once. So A, B, C, D, E. It is a Hamiltonian path as each vertex is coming exactly once. Now what is a Hamiltonian circuit? If there is an edge between the starting and ending vertex, we have an edge between E and A. So it becomes a Hamiltonian circuit. So how we go ahead with this? We start with any of the vertex. Let us suppose we start with A, mark it as visited. Now we go to its adjacent. Let us suppose the graph is like this. We have B and D. We go to any of its adjacent. Let us suppose we go to D. Then any of its adjacent. Let us suppose we go to E. Then any of its adjacent. Let us suppose C. Okay. And if in the end we are able to mark all the vertices, which means we have all the 5 vertices, then we have C to B and B to A. If in the end we are able to mark all the vertices and we can end in A, which means we have a edge from B to A, then we are able to do this. But if we are not able to reach at any such point, let us suppose it was something like this, then we go from A to D to C to E, A to D to C to E, and then we can't, all its are visited. Like we can go to A but B is left out. Here we need to do a backtrack to C and then traverse all other options like A to D to C to B. Here now it becomes a Hamiltonian path. Okay, so we need to check for all possibilities. So Hamiltonian circuit is based on backtracking, as we need to backtrack whenever we do not get a possible option. So answer is P is mapped to 2, Q is mapped to 3, R is mapped to 4 and S is mapped to 1. So option C is correct. This question belongs to programming subject and was asked in GATE CSE 2015. So the question states, the output of the following C program is. So we have a function f1 which takes two parameters a and b, f2 which takes two pointers a and b, and a main. So what happens? Let me draw the memory for each. So in stack we have a memory for main. So first main is post. So main will have a equals to 4, b equals to 5 and c equals to 6. Let us suppose it is at the address 1000, it is at the address 2000, it is at the address 3000. Okay, now it calls, main calls f1. So main calls f1. f1 is pushed into the stack with the values of a and b, which means 4 and 5. It is called by value. Now f1 creates two variables a and b and store 4 and 5 in it. Now it creates a variable c which has garbage. Now it does garbage c equals to a, so c will have 4, a equals to b, a will have 5, b equals to c, b will have 4. Here it swapped locally, not globally. Now f1 completes. So these changes are lost. Now this is done, this is done. So f2 is called now. So f2 is called with the address of b and the address of c. So what is address of b? It's 2000 and the address of c, it's 2000. Address of c is 3000. Now f2 is called. f2 again creates two pointer variable a and b. A stores the value 2000, c points to 3000. A and b, and it has another pointer variable c. So c will store the value which is pointed by a, which is pointed by 2000, which means 5. So c will hold 5. A will hold the value which is pointed by b, which means 3000. So a will hold the value which is pointed by 3000. 3000 means 6. So a will hold 6. B will hold the value which is pointed by c, which means 5. So b is 3000. 3000 will hold the value 5. Let me check if it is done correctly or not. So c, our c will hold the value which is pointed by this 2000. So 2005. So c will hold 5. A will hold the value which is pointed by b, which means 2000 will hold the value pointed by 3000. So 2000 will hold the value pointed by 3000. I think there is some mistake over here. Let me try to do it again. So we have 4, 5, 6. We have values 4, 5, 6. Okay. Let us see. So C will hold the value which is pointed by 2000. So 2000 has 5, so C will hold 5. A is 2000. 2000 will hold the value pointed by 3000. So 2000 will hold the value pointed by 3000, which is 6. Here 3000 will hold the value which is pointed by C, which is 5. 3000 will have 5. So 3000 will have 5. Okay. Now I think it's correct. We need to print C minus A minus B. So C is 5, minus A is 4, B is 6. So 5 minus 4 is 1, 1 minus 6 is minus 5. So answer is minus 5. This one was called by reference and this is called by value. Answer is minus 5. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, if g of x equals to 1 minus x and h of x equals to x by x minus 1, then we need to find the value of g of h of x divided by h of g of x. So what is g of h of x? G of h of x equals to g of, what is h of x? X by x minus 1. So just consider this as capital X and substitute in this. So we have g of x which is equals to 1 minus x which is equals to 1 minus What is capital X? It's x by x minus 1. So we get x minus 1 minus x by x minus 1. So g of h of x equals to minus 1 divided by x minus 1. Now what is h of g of x? So now we have h of g of x. So it's equal to h of what is g of x? 1 minus x. Consider this as capital X. What is h of capital X? It's capital X divided by capital X minus 1. Replace capital X by 1 minus x. 1 minus x minus 1. 1 gets cancelled. So it's 1 minus x by minus x. So it's minus x divided by 1 minus x. So what is g of h of x by h of g of x? It is equal to, what is the value of h of x? H of x, let us see each of the, what is this? H of x is x by x minus 1 and g of x is 1 minus x. So is it equal to this? Yes. Minus minus gets positive. Then we have x minus 1 and 1 minus x. So what is x by x minus 1? So x by x minus 1 is h of x. And what is 1 minus x? It's g of x. So answer is option A, h of x divided by g of x. This question belongs to data structure subject and was asked in GATE CSE 2015. So the question states, the height of a tree is the length of longest route to leave path in it. So if we have a tree like this, then the height is length of longest route to leave path, which is 1, 2, 3, 4. So its height is 4. And what are the number of levels? Levels equals to height plus 1. Height plus 1, which is 5. This is first level, second level, third level, fourth level, fifth level. If the maximum and minimum number of nodes in the binary tree of height 5 is, so we have been given a height 5, we need to find the maximum number of nodes in it. So height is 5. So what are levels? Levels is height plus 1, so level is 6. Okay. So in which case do we get a maximum number of nodes? So max node occurs in a complete binary tree, CBT, in which all levels are completely fit. See here. For a height 1, like this, height 2 is like this, height 3 is like this. Let us try to derive a formula for this. So number of nodes at first level is 2 to the power 0 or 1. At this level is 2 to the power 0, 2 to the power 1, 2 square, 2 cube. So for height 3 we go till 3. So for height 5 we will go till 5, 2 to the power 0 plus 2 to the power 1 plus 2 square plus 2 cube plus 2 to the power 4 plus 2 to the power 5. Let us try to form a GP series and make it a general term up to 2 to the power h. So we get A, which is 2 to the power 0 into, what is the formula for sum? Sum formula is A into r to the power n minus 1 divided by r minus 1. So what is A? A is 2 to the power 0 or 1. What is general term? It's 2 to the power n. What are the number of terms? It's h plus 1 minus 1 divided by r is 2 minus 1. So we get the answer to be 2 to the power h plus 1 minus 1 or 2 to the power level minus 1. So here it will be level is 6 to the power 6 minus 1, which is 63. So first one we got is 63. And what is the case for minimum number of nodes? Min nodes means skewed tree. Skewed tree or one node per level. It can take various forms like this: 1, 2, 3, 4, 5, 6, or like this 1, 2, 3, 4, 5, 6. It can take various forms, but it will have 6 nodes. So max is 63, min is 6. Answer is option A, 63 and 6 respectively. This question belongs to programming subject and was asked in GATE CSE 2015. So the question states, what is the output of the following C code? So this is our C code. Assume that the address of x is 2000 in decimal and an integer requires 4 bytes. So an int requires 4 bytes and x, which is a 2D array, So we have a 2D array X with 4 rows and 3 columns, and it has a starting address of 2000. So the entries are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So this has address 2000. It occupies 4 bytes, so it will have address 2004. Let me use a different link. It will have 2004, 2008, 2012, as we are assuming by default row major, which means the entries will be stored row by row. So we need to tell %u what is the value of x plus 3. Okay, so x plus 3, what is x? X is 2000. As it is a 2D array, so plus 3 means skipping 3 rows. 3 rows. What is each row size? Each row size is 3 items, and each item occupies 4 bytes. So it's 24, 14, 12, 12 and 36. So it's 2036. So its answer is 2036. Now what is the value of, so we got 2036. Now if we put star over here, which means we need to tell the content is 2036. But as it is a 2D array, so 1 star means going inside the row. So what is 2036 item? It's 8, it's 2012, it's 2016, 20, 24, 28, 32, it's 2036. So we come over here. Going inside these row, it will have the same address 2036. So second one also will be 2036. If we want to go to this item, then we need to apply 2 asterisks with 2036. In that case, it will give 10, but a single asterisk will give only 2036. Now we have star x plus 2. So x is 2000 plus skipping 2 rows. So each row has 3 items with 4 bytes plus 3, and we have 4 star over here. Okay. So we have star 2024. Okay, we have, there is some discrepancy. Let us do it carefully. Star x plus 2 plus 3. Okay, so it's 2000. Skipping 2 rows is with 3 items, each with 4 bytes plus 3. So we get star 2024 plus 3. Star gets us inside the row. So we get inside the 2024 row, which means we come over here. Now skipping 3 items, which means, so we come inside this row. Now again the address is 2024 only. But here each jump will be corresponding to 1 item. Initially each jump corresponds to 1 row. Here each jump will corresponding to 1 item. And we have done 1 star. So plus 3 items. Each item has 4 bytes. So it's 2024 plus 12. It's 2036. So here we got 2036. So answer is option A. All 3s are 2036. This question belongs to Theory of Computation subject and was asked in GATE CSE 2015. So the question states, consider the DFAs M and N given above. The number of states in minimal DFA that accept the language LM intersection LN is. So let us analyze the DFA M. So it has A and B. Any number of loops of A and B. So A plus B whole star, then a A. So it's nothing, just the example of strings it can accept are A, BA, 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 BB, B, A, B, A. So anything ending with A is accepted by this DFA. What is regular expression for N? It is similar to M, but we just have ending with a B. So any loops of A and B ending with a B. So examples are B, AB, BB, AB, double, triple B, and so on. So it's ending with B. Now what is LM intersection LN? See here, there is no string common in them. So it will accept phi or null string. So the DFA for this is A comma B. with no final state. So number of states are 1, which is a single non-final state, and this is the minimal DFA. So answer is 1. This question belongs to computer organization subject and was asked in GATE CSE 2015. So the question states, consider a non-pipelined procedure. So we have a non-pipelined processor, a processor in which pipelining is not implemented, with a clock rate of 2.5 gigahertz. So its frequency is of non-pipelined is 2.5 gigahertz. And average cycles per instruction of 4. So what are the number of clock cycles per instruction here? There are 4. The same processor is upgraded to a pipelined processor. Now we have pipelined version of the same processor with 5 stages. So number of stages equals to 5. But due to internal pipeline delay, the clock speed is reduced to 2 gigahertz. So frequency of pipeline processor is 2 gigahertz. Also there is no stalls in the pipeline. So no stall in the pipeline means if we have 5 stages, then each instruction will take 1 clock cycle. As at each clock cycle we will be getting 1 instruction out of the final stage. So CPI of pipeline processor is 1 and non-pipeline is 4. The speed up achieved in this pipeline processor is, okay, so see, we have frequency as 2.5 gigahertz. So 1 cycle time is 1 by frequency, so it's equals to 1 by 2.5 gigaseconds. Okay, so 4 CPI like, and 1 instruction time equals to 4 CPI. 4 CPI equals to 4 into 1 by 2.5 gigasecond. Now let us do the same for pipeline processor. So 1 cycle time equals to 1 by frequency of pipeline. It's equals to 1 by 2 gigahertz. So it's equals to 1 by 2 gigasecond. And 1 instruction time equals to 1 CPI. So it's equals to 1 by 2 gigasecond. Now what is the speed up? Speed up means how much faster we are able to execute the new processor. So speed up equals to instruction time in case of non-pipeline processor divided by instruction time in case of pipeline processor. So non-pipeline was taking 4 by 2.5 gigasecond and pipeline is taking 1 by 2 gigasecond. 1 by 2 gigasecond. So we get 8 by 2.5, or we can say 80 by 25, which is equals to 3.2 is the speed up achieved. So answer is 3.2, which means pipeline processor is able to work 3.2 times faster than a non-pipeline processor. So if a non-pipeline processor takes 3.2 seconds for an instruction, then pipeline processor will take only 1 second for that instruction. So answer is option A, 3.2. This question belongs to compiler design subject and was asked in GATE CSE 2015. So the question states, the least number of temporary variables required to create 3-address code in the static single assignment form for the expression q plus r by 3 plus s minus t into 5 plus u into v divided by w is. So we need to do how many temporary variables in the SSA form is required for this expression. So let us see. In the compiler design, basically SSA form or the static single assignment form is a property. It is an intermediate code generation. It's type of an intermediate code in which each requires that each variable should be assigned only one, which means each variable assigned exactly once, and every variable is defined. Every variable is defined before its use. See, and the existing variables are split into 2 versions of the new variables. So we will be needing a temporary variable for storing the result of each binary operation as static single assignment form, which means the variables cannot be repeated in LHS. So we have RHS and LHS. So LHS will have all the distinct variables. So how will we go ahead with this? We have this q plus r by 3. So what we have? We have q plus r by 3 plus s minus t into 5 plus u into v by w. So first we will create temporary variable t1 for r divided by 3. This is done. Then we will create another variable for t into 5. t2 equals to t into 5. So what will happen? We will have this done t into 5. Then we will create a variable t3 equals to u into v, because we need to follow the BODMAS rules. So first divide and multiply is done from left to right. Then we have t4 equals to t3 by w. So this part is also done. Now we have t5 equals to q plus t1. So we have q plus t1. So this is also done. This one is also done. Now we need to do this. So t6 equals to t5 plus s. So this is done. Now we have to do t7 equals to t6 minus t2. So this part is also done. Now we have to do t8 equals to t7 plus t4. So this is entire t8. So we need 8 temporary variables t1 to t8. So answer is option A, 8. This question belongs to engineering mathematics subject and was asked in GATE CSE 2023. So the question states, suppose L equals to PQRST is a lattice represented by the following Hasse diagram. So here a Hasse diagram has been given. For any xy belongs to L, not necessarily distinct, x join y and x meet y are the join and meet operations of x and y respectively. So this represents join operation. These are standard notations and this represent meet operations. What is join? Join is least upper bound and meet is greatest lower bound. Let PR be the probability that an element, let L cube equals to x comma y comma z such that xyz belongs to L with a set of all ordered triplets of the elements of L. So we have triplets represented by x comma y comma z. Let PR be the probability that an element x comma y comma z belonging to L to the power 3 chosen equiprobably satisfies this. Then this is the probability. If it satisfies, then PR is the probability. Now we need to tell what is the value of PR. Okay. See, what is L cube? L cube is nothing but its triplets. So L cube is triplets of 3, which means triplets with a size 3. And here we have 5 elements P, Q, R and T. Now suppose if we assume that there is repetition possible, as there is nothing written about non-repetition, then repetition is possible. The number of ways to select triplets out of 5 items is 5 into 5 into 5. So number of elements in L cube is, cardinality of L cube is 5 into 5 into 5, which is 125, which is the number of ways we can choose 3 elements from 5 elements with a repetition being allowed. Okay. Now assume that we take x equals to t. Now then the given condition of L is satisfied for any y and z. Why and how? Let me tell you. If we have x and t, then what is the least upper bound? Then the least upper bound and greatest lower bound. You can see if you take any of those values, then it will satisfy for any yz, be any yz. So number of ways of selecting y and z will be 5 into 5 with repetition allowed 25 ways. So we got 25 options with x and t and y and z being any of these 5 values. So 25 we got. So answer options 25 plus. Now if we have x as r, y and p, y as p and z as p, then the condition is satisfied. Let me show you how. If we have r join y is p and p, it should be equals to r or p meet r or p. See, least of meet of two things, P and P will be P, so we will have R or P. X and with greatest lower bound with X will be X, so we get R or P. So these are same, so we got one more answer, so total we got 26. Okay, so with X as T we got 25, as with any YZ, and with X and as R, Y as P and Z as P we got one more options. So it should be PR should be at least 26 by 125. Total options are 125 and we got 26. So it is definitely greater than 1 by 5, as 1 by 5 is 25 by 125. So it's definitely greater than 1 by 5. Okay. So our PR is definitely greater than 1 by 5. Okay. So PR is 0 is false. This is also false. Now we have to see whether PR is in the range of 1 by 5 to 1 or PR is 1. So to do this we need to find a condition in which this is not satisfied. Okay, so for this assume that we have X as Q, Y as R and Z as S. Now let us see, we have X as Q, Q join R meet S. What is the value of this? R meet S, R and S lower bound will be P. So Q or P, least upper bound of Q or P will be T. So we got T. Now let us see the RHS. What is RHS? RHS will be X or Y and X or Z. So what is X or Y? X or Y is Q or R and R or S. So what is the least upper bound of Q and R? It's T. T and what is least upper bound of R and S? It's T. What is T and T? It's T. Okay, so we can see, but what is this? Let us do, this is T and it's got T. Let us do it one more time. Q or R and S. Okay, what is its value? What is R and S? Means meet of R and S. So meet of R and S will be P. Yeah, I got this, I have done this wrong. R and S of lower bound, greatest lower bound, it will be P. So Q or P, least upper bound of Q and P will be, it will be Q. So it's Q and it's T. So they are not equal. So we got that it won't be equal to 1. So the correct answer is option D. It will be in the range of 1 by 5 to 1. And even if it is equal to over here, even then it will come in this range as we got more than 1 by 5. So answer is option D. This question belongs to Theory of Computation subject and was asked in GATE CSE 2015. So the question states, consider the NPDA where as per usual convention Q is the set of states which consist of Q0, Q1 and Q2. Sigma is the input alphabet which consists of 0, 1. T is the stack alphabet consisting of 0, 1, perpendicular. Delta is the state transition function and Q0 is the initial state. Perpendicular is the initial stack symbol. So for NPDA, it's nothing but DFA with a stack. So it has the initial stack symbol perpendicular. And F is the set of accepting states. So Q2 is the only final state. So F has only Q2. The state transition is as follows. Now it asks which one of the following sequences must follow the string. So we have string 101100 and we have, let us suppose it is L1. So what must follow L1? So what is the value of L2 so that this entire L1 plus L2 is accepted by our automaton? So that the overall string is accepted by the automaton. Let us analyze the automaton. So what happens? So Z means whatever is present in the stack. So if we get 1 as the input alphabet, then we are pushing it to stack. 1, then we push 1 into stack. And if we get 0, then we push 0 to the stack and come over here. We keep on pushing. And it is non-deterministic, which means on epsilon, we are also doing nothing and coming over here. And also on 0, 1. Now here, if the top is 1, Z, which means the stack top is 1 and we are getting a 0, then we are just popping each one for a 0. So if we get a 0, then we pop 1, and if we get a 1, then we pop 0. Pop 0. So basically we are matching 0 with a 1 and popping 1. So we are matching 0 with its complement and 1 with its complement. Then if we reach to the end of the stack with epsilon, then we reach to the final state. So it is acceptance by final state. So what type of strings it will accept? So it will accept strings like x, 0, x reverse complement. Why? Because we have x, then we have 0, because it can be an odd string or it can be an even string. X reverse complement followed by x, or x 1 x reverse complement. See, we can have middle symbol either 0 or 1, because, and these two are odd cases of odd length, and this one is case of even length. Now it is accepting matching x, so it will first push 1 for 1 and 0 for 0, and then it will match 0 with a 1, which means the reverse of its complement. So what we have 1 0 1 1 0 0. What is x reverse? X reverse is 0 0 1 1 0 1. What is its complement? Its complement is 1 1 0 0 1 0. So this is the second part. So answer is 1 1 0 0 1 0. See, we have this 1 0 1 1 0 0. So what is its reverse and complement? So its complement is 0 1 0 0 1 1, and its reverse is 1 1 0 0 1 0. So answer is 1 1 0 0 1 0. But see, here we have only 5. Only 5 things are given. So what we assume? We assume that 0 is the middle symbol. So we assume 0 is the middle symbol, and we find reverse and complement of this 1 0 1 1 0. So what is reverse of this? It's 0 1 1 0 1, and complement is 1 0 0 1 0. So if it had been 6 options, then answer was this 6 length, and for 5 length answer is this. So answer is option B, 1 0 0 1 0. This question belongs to programming subject and was asked in GATE CSE 2015. So the question states, consider the following pseudocode where x and y are positive integers. So the code looks like this. We have begin and end with value of q assigned to 0, value of r assigned to x. Now we are running this condition while r is greater than or equal to 1. And here we are decrementing the value of r by y and incrementing q by 1. The post condition that needs to be satisfied after the program terminates is. So at this point we need to tell which of the conditions need to be satisfied for this. See what happens. Initially q is 0 and r is x. So we run this loop till r is greater than y, and when the loop terminates, so at the termination condition, what is the termination condition? Loop terminates when r becomes less than y, because when r becomes less than y, we come out of this while loop. Okay, we come out of this while loop when r becomes less than y. How many times will it run? See, we are decrementing r by y each time, which means if r is 10 and we are decrementing it by 3 each time, then it will run r by y times. See, r by y times, but the value of r is initially x, which means it will run x by y times. So loop runs x by y times, and each time we are incrementing q. So the final q value will be x by y. Okay, now see what will be r. See, suppose for this condition we are decrementing it by 3 each time. So initially it will be 10, then it will become, and suppose y is 2. Suppose y is 2. So what happens? Initially r is 10. Okay, x is 10, so r becomes 10, and y is 2. Let us suppose y is 3. Then we are decrementing it by 3 each time. So first r is 10, then it becomes 7, then it becomes 4. Then when it becomes 1, we terminate the loop. Okay, what is this 1? How can we find out this 1? This 1 can be easily found out by 10 mod 3, or we can say x mod y. So the value of r, final r value will be final r equals to x mod y will be the final r. Now we have to tell See, now this condition, we have to tell what is the final R value. So what is R? Initially it is R equals to Qx plus Y. Let us see. R equals to, what is Q? Q we have incremented here by 10 by 3 times, which means 3 times. So Qx, no, it's increasing the value, no, it's false. X equals to Qy plus R. So X is our 10, Q is 3, Y is 3, 3 into 3, 9, and R is 1. So this is satisfying. Why is it satisfying? It is satisfying because our initial X value, what will be equals to? Q is the number of iterations. So it is equal to number of iterations into what value are we decrementing. So we are decrementing Y value. So to find our initial value, if we are decrementing something some number of times, then we can multiply it, and we have some remainder. Remainder was in R. So this will give us our initial value X. So correct answer is X equals to Qy plus R. It's nothing but, it is a quotient, dividend, divisor, and remainder. It's nothing but that only. So answer is option B. This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, an algorithm performs log n raised to the power 1 by 2, which is under root of log n find operations, n insert operations, under root of log n delete operations, and under root of log n decrease key operations on a set of data items with keys drawn from a linearly ordered set. For a delete operation, a pointer is provided to the record that must be deleted. For a decrease key operation, a pointer is provided to a record that has its key decreased. Which one of the following data structures is most suited for the algorithm to use if the goal is to achieve the best asymptotic complexity considering all operations? So we have to do find operation. How many log n, under root of log n operations? We have to do delete operations. How many n, under root of log n delete operations? We have to do insert. How many n insert operations? We have to do decrease key. How many, under root of log n? Such that we are provided, in case of decrease key, we are provided a pointer, and in case of delete, we are also provided a pointer. For find, we do not need a pointer. For insertion, we do not need a pointer. Okay, now let us see how we can do this. So these are our options that are given to us. Okay, let us write them. We have unsorted array, we have min heap, we have sorted array, we have sorted doubly linked list. And what all operations are there? It's find, it's delete, it's insertion, and it's decrease key. Okay, let us analyze each one of them one by one. So we have been given an unsorted array. Okay, so suppose you are given an unsorted array and you have to find a particular item. So how will you find it? You will find it basically by performing a linear search. Linear search will take order of n complexity. And how many find operations do we need to do? Log n. So total complexity is n into log n to the power 1 by 2. And we just need a scan. Now we have delete operation. So how many deletes do we need to do? Under root of log n. So suppose we are given a pointer to this node. So we need to delete this node and shift all of them in front. But there is an optimized approach. Swap this with this, and then suppose 5 is here and 6 is here, and we need to delete 1, 10, 3, 8. We need to delete 5. So swap 6 with 5 and then delete it. So it can be done in order of 1. So log n operations can be done in log n raised to the power 1 by 2, 1 into log n. Okay. All are big O. All are big O complexities. Now insertion operation. Suppose we want to insert an item, then just insert at the end in order of 1 complexity. So for n insert operation, so total time will be order of n into 1. Decrease key. We are given the item whose key we want to decrease. So we just go with the pointer, we go to that location and perform the decrease key. So one decrease key takes order of 1 and log n decrease key takes log n under root of log n. Okay. Now we have a min heap. So how min heap will be given to us? Min heap is given nothing, just like an array only. Okay, and it is an ECBT, which is almost complete binary tree. Okay, almost complete means, and all the levels will be filled and last level will be filled from left to right. Now we need to do under root of log and find operations. So for finding an item in mini, we just need to scan this entire array. So complexity will be for log n operations, and one operation takes order of n. Now we have delete operation. See, in this min heap, when we want to delete an item, we just replace it with the last item and perform the heapify. So replacing takes order of 1 and heapify takes order of log n. So complexity would be order of log n for one operation, and for under root of log n it will be multiplied by n to the power 1 by 2. Now we have insert operations. So how do we insert an item in heap? So we insert at the end, and similarly we apply the heapify. So heapify take log n time for one operations, and we want to do n insertions. So total time is n into log n. Now we have decrease key. So for decrease key, we first need to find that item, but we are already given a pointer to that, so it can be done in order of 1. Now after decrease key also we need to do the heapify. So heapify take log n for one item, and we have log n to the power 1 by 2 decrease key operations. Okay. Now we have a sorted array. Sorted array means we need to make sure that it remains sorted. For mini, we need to satisfy its property after every operation. For unsorted array, we need to satisfy for doubly linked list also, and for sorted array also. So for sorted array, we need to find the item. So how will we find it? We can just apply binary search. So binary search takes log n time for one operation, and we have log n to the power 1 by 2 operations. So the total complexity is log n to the power 3 by 2. Now we have delete operations. So how many delete we do have? We have log n delete operations. So how do we delete the item? We are given a pointer, so we just go and delete the item, replace it with the last and delete it. But then we need to make sure that it remains sorted. So for sorting, it will take order of n time for 1, and for n decrease key, it will take n to the power log n to the power 1 by 2. Okay, now we have insertion operation. So suppose we have given a sorted array, so we insert at the end, but we need to perform one pass of the insertion sort, as we need to check at which position that new item should come. Let us suppose it was 1, 5, 10, 17 and 21, and we added 6. Then we need to check whether 6 is less than this, and it will take in worst case order of n time. So complexity is n for one insert, and for n insert it's multiplied by n. Now we have decrease key operations. Now we have under root of n decrease key operation. So one decrease key will take order of 1, as we just have a pointer, but we need to again find the actual position of that. Suppose it's decreased to 23, then we need to shift it over here. So it will take order of n time for one item, and for we need to perform n to the power 1 by 2 decrease key operations. Now we have sorted doubly linked list. So what is in sorted doubly linked list? So it has a pointer to the previous node and to the next node, like this. Okay, and it's already sorted. So how do we perform a find operation? So suppose it's sorted. So can we do binary search? No, we can't do binary search, as we need to maintain a pointer for all the items. Thus we just do a linear search for a sorted doubly linked list. For one item it takes n, and for under root of log n it's multiplied by under root of log n. Now we have delete operations. Suppose we want to delete this, then we just come over here, delete it and change the links like this. It can be done in order of 1. So order of 1 for one delete operation, and total delete are multiplied by log n to the power 1 by 2. Now we have insert operations. So we insert at any position. Suppose we want to insert, we have 5, 10, 15 and 20, and we want to insert 8. Then we find the actual position in order of n. We can find the position in order of n, and then insert in that in order of 1. So insert operation, one insert takes order of n. How many insert do we have? We have n inserts, so it's n into n. Now we have decrease key. So if you want to decrease a particular, we can decrease in order of 1, but then again we need to sort the particular list, and sorting can be done in order of log n. Sorting can be done in order of n by using the insertion algorithm. Same. Find the actual position and insert in order of n. See, we can delete it in order of 1, but then we need to find the actual position in order of n, one pass, and then we can insert it at that new position in order of 1. So complexity is order of n for one item, and for under root of log n, it's multiplied by under root of log n. Now see, which one is the best? We need to tell overall best. Okay, so let's see. It's n square n log n. So insertion, this one is best. Okay. For decrease key, this one is best. For delete, both these are best. And for find, this one is best. Okay. You can easily see that unsorted array is best for most of the item. And even for this find, it's only log n times. It's only a n by log n times more than sorted array, the best one. So unsorted array is our answer, option A. It's the best algo for all these algorithms, for all these operations: find, delete, insert, and decrease. So answer is option A, unsorted array. This question belongs to data structures subject and was asked in GATE CSE 2015. So the question states, consider a max heap represented by the array. Now consider that a value 35 is inserted into this heap. After insertion, the new heap is what? We need to tell. Okay. So what is a max heap? Max heap means any parent or any node has its value greater than all nodes in its left and right subtree. Okay. So max heap is basically an almost complete binary tree, ACBT, which means all the levels, upper levels will be completely filled and the last level will be filled from left to right. Okay, and it can be represented by an array. Now let me try to draw this heap for you. Okay, see, here we have 40 at index 1, then 30 at index 2, then 20, 10, 15, 16, 17, 8, 4. Okay, so let's first see whether it's max heap or not. 40 is greater than everything, yes. 30 is greater than all these, yes. 20 is greater than all these, yes. 10 is greater than all these, yes. Yeah, so it's a max heap. Now we are asked to insert 35 into this. So when we are asked to insert anything, we insert it at the last index 35. Now we try to do the heapify. Heapify means making a particular tree a heap, a max heap. Max heap or a min heap, in this question a max heap. So let's see. We will start from parent of 35, which is 15. So see, whether 15 is greater than 35, no. If it is not, swap both these values. Now go to its parents. Whether 30 is greater than 35, no. Swap both its time. So we have 35 and 30. Now we will read it level by level, left to right. So the nodes are 40, 30, 20, 10, 30, 35, 20, 10, 30, 16, 17, 8, 4, 15. So we have 40, 35, 20, 10, 30, 16, 17, 8, 4, 15. So answer is option B. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, consider the following 2 cross 2 matrix A where two elements are unknown. So we have A and B as unknowns and are marked by A and B. The eigenvalues of matrix are -1 and 7. So delta 1 is -1 and delta 2 is 7. What are values of A and B? So eigenvalues have a property that sum of eigenvalues, which means delta 1, sum of eigenvalues, which means delta 1 plus delta 2 or gamma 1 plus gamma 2 equals to trace of matrix. Okay, what is trace? Trace is the diagonal element sum. Diagonal element sum. So we have gamma 1 plus gamma 2. So gamma 1 is -1, gamma 2 is 7 equals to trace is 1 plus a. So 1 plus a equals to 6, a equals to 5. So we got a equals to 5. Now we have another property that the product of eigenvalues equals to determinant of matrix, determinant of A. So product is minus 1 into 7, determinant is 1 into A minus B into 4. So 1 into A minus B into 4. So we have minus 7 equals to A minus 4B. So minus 7 equals to A value is 5 minus 4B. 4B equals to 12, B equals to 3. So answer equals to A equals to 5, B equals to 3, option D. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, let G equals to V comma E be a simple undirected graph and let S be a particular vertex in it called a source. So we have source vertex represented by S. For x belongs to V, let dx denote the distance of in G from S to x. So from source S to any vertex, let us suppose x, the distance is denoted by dx. Okay. A BFS is performed starting at S. So we have a graph G and we are performing BFS starting at the node S, which is the source node. Let T be the resultant BFS. So we get the BFS tree. Tree T. BFS tree. Breadth first search tree. If UV is an edge of G, if we have a edge UV in G, that is not in T, which means U and V are not connected in T, then which of the following cannot be the value of du minus dv? Okay, so we can do this easily with the help of counter examples, okay, or with the help of examples. Okay, so first let us consider a diagram like this: S, U, V, and X. So see, S is the start node, source, and so what happens? Now see, what is du? Du is the distance from source to U. It's 1. What is dv? By default, every weight should be considered as 1. It's default in case of graphs. What is dv? dv is 1. So, and what is our BFS? BFS will have S, U, V, X. It can have like this. So BFS don't have UV. And what is du minus dv? It's 0. So 0 is possible. Okay. And why this happens? So the case of 0 occurs when both u and v have an edge from a common node T. So we have a common node and both u and v have an edge from a common node. And u and v are also connected. And T is the shortest. T comes in the shortest path from S to U to V. So in the shortest path, T comes to u and v. So this is the case that we have discussed over here. Now let us discuss the case for option B. Okay. So option B states that now we have, let us consider the case for 1 or minus 1. So consider graph like this: S, U, V, or make it as X, V, U. Okay, perfect. All the weights are 1. Now see, now what is our du? Du is distance from S to U, it's 2. dv is 1. And what is our BFS? BFS won't have UV edge. So BFS can have edge like this and UV won't occur in the BFS. And what is du minus dv? It's 1. So 1 is also possible. And what is, and if we replace, see here, if we can replace u and v, then also same case will occur. Here we will have v, here v, and here u. Okay, then du minus dv is minus 1. Okay, because in case du is 1 and dv is 2, so du minus dv is minus 1. So 1 and minus 1 are possible. And when this case occurs, so du minus dv, one case or minus 1 case occurs when v and another node t. So we have v and another node t. So let us suppose like this: we have source T, V, and U. So it occurs when V, which is this one, and another node T are in the shortest path from S to U. So from S to U, both these should come. So from S to U, both T and V should come in between. Okay. And both T and V must be siblings, which means they have same distance from S to both T and V, causing TUS to be in BFS tree and not UVH. So TUH will be there and not UVH. Okay. Now, what is DU minus DV? Equals to 2. Will this case occur or not? This case is not possible because the BFS, see we have a BFS, so either first we will visit U or we will visit V, and we have a distance from U to V. So while traversing DFS, either we will first visit U or we will first visit V. Now in either case we will put all the neighbors of U. Suppose we visit U first, then we put all the neighbors of U first. So in those neighbors V will also come. Since V is a neighbor and V is not before visited before, if we assume, then V will come in the next iteration, and in that case they will have a distance of 1 and not 2. 2 is not possible. 2 would be possible if U is not a neighbor of V and is connected to 3. Then 2 is possible. But as U is our neighbor, so 2 is not possible. So we need to tell which of the following values cannot be possible. So A, B, C and are possible and D is not possible. So answer is D. 2 is not possible. Option D. This question belongs to Digital Logic Design subject and was asked in GATE CSE 2015. So the question states, the binary operator not equal to is defined by the following truth table. So we have a binary operator not equal to, and for this truth table is given over here. Which one of the following is true about the binary operator? We need to tell both commutative and associative, commutative but not associative, not commutative but associative, neither commutative nor associative. So when can we say that a binary operator is commutative? So if it is commutative, then P not equal to Q should be equivalent to Q not equal to P. Let us verify it. Let us take P as 0. So 0 not equal to 1, and here 1 not equal to 0. So what is 0 not equal to 1? It's 1. 1 not equal to 0 is 1. Okay. So it's commutative. We can't prove that it is commutative. We need to basically find a possible alternative to prove that it is not commutative. But you can easily see you won't be able to find any alternative. Associative. It would be associative also. Associative means P not equal to Q not equal to R should be equivalent to P not equal to Q not equal to R with associativity of brackets change. You can see you won't find any tuples which do not satisfy this. There is an easier method to do this. See, if you analyze this truth table, you will easily get to know that it is nothing but the truth table of the XOR. As 0 XOR 0, what is A XOR B? A XOR B is AB complement plus A complement B. So 0 XOR 0 is 0, 0 XOR 1 is 1, 1 XOR 0 is 1, 1 XOR 0 is 1, and 1 XOR 1 is 0. And XOR is both commutative and associative. So either you can try to find out a case in which commutativity and associative fails, or you try to find out what operation it represents. So it represents XOR operation, and it's both commutative and associative. A XOR B equals to B XOR A, and A XOR B XOR C is equivalent to A XOR B XOR C. So answer is option A, both commutative and associative. This question belongs to Database Management System subject and was asked in GATE CSE 2015. So the question states, consider an entity relationship model with the entity sets E1 and E2 are connected by a M2N relationship. So we have entity set E1 and entity set E2, and they are connected by a many-to-many relationship M2N, which is both sides many is there, R12. Okay, and E3 is connected by an 1 to n relationship. So here we have 1 to n relationship with E3, with 1 on the side of E1 and n on the side of E3. Relationship R13. This is R13. E1 has two single valued attributes, A11 and A12. So we have A11 and A12. They are single valued attributes such that where A11 is the key attribute. So key attribute is represented by a single underline. E2 has two single valued attributes, A21 and A22. Okay, of which A21 is the key attribute. Okay. E3 has two single valued attributes, A31 and A32, of which A31 is the key attribute. So A31 is the key attribute. Okay. Now the relationships do not have any other attributes, which means these relations do not have any attribute. If the relational model is derived from above ER model, then the minimum number of relations that would be generated if the above relation is in 3NF is. So what happens is these relations will also have tables with primary key of both left and right. So A11 and A21 would be over here for many to many relation. Okay, and here we will have A31 and A11, but we can easily combine them. So there is a table for this. You can easily remember this table. So if we have one to many relationship, we have many to many relationship, one to one relationship with both partial relationships, or one to one with at least one total participation. Here both are partial participation and here at least one is total participation. So what happens? See, in one to many we can combine relation on many side. On many side it will get combined. So for one to many this will combine to many side. Okay. For M to N can't be merged. They can't be merged. So for this we had three relations and two foreign key. This foreign key pointing to this and this pointing to this. Now we will have two relation and one foreign key. Okay, after combination in 3NF. 3NF combination number of relation and foreign key. For many to many it will remain the same. We will have three relation and two foreign key. Which means this will point to this and this will point to this. So this can't be combined. One to one with partial. We can merge with left or right. So we will have two relation and one foreign key. In case of total participation, we will have can be merged. All three can be merged. Three can be merged. So we will have one relation and zero foreign key. So here many to many they can't be merged. One to many it can be merged on many sides. So what all relations do we have? So one relation is for E1. So we have A11, A12 with A1 as our foreign key, our key. We have a relation for E1. Then we have another relation for E2 with A21 and A22. Okay. Then we have another relation for R1 as it can't be merged with A11 and A21. Then we have a relation for E3. And this is merged over here. So here we will get A31, A32 and A11. This is the relation for, this is the fourth relation. So we have first relation, second relation, third relation, fourth relation. We would have been 5, but this got merged with this. So answer is 4, option A. This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, the graph shown below has 8 edges with distinct integer edge weights, which means all edge weights are distinct and integers. The minimum spanning tree is of weight 36. So MST has a weight 36. It can be found out by Kruskal or Prim's any algo and contains the edges AC, BC, BE, EF, DF. The edge weights of only those which are in MST are given in the figure. So all these edge weights are of the minimum spanning tree. The minimum possible sum of weight of all edges of this graph is. So we need to tell the weight for A, B, C, D and EF. Okay. So see, what happens in minimum? We always try to take the least edge in the MST. So consider this cycle AB ABC. Here, if this value had been lesser than 9, then it would have been taken instead of 9. So which means this value will be definitely greater than 9. As suppose if it was 7, then we would have taken this edge and discarded this one. Thus, it should be definitely greater than 9. And as all edge weights are integer and distinct, thus it should be 10. Okay, now consider this cycle. For this cycle, similarly, it should be greater than 4 and 6. So next possible integer is 7. And for the cycle B, C, D, E, it should be greater than all these values 2, 7, 15. So the next possible greater value is 16. Okay, so what is the sum? Initially it was 36. Now we have added 16, 7 and 10. So it's 33 and it's 36. So it's 69. So answer is option A, 69. We just need to make sure that we assign a value greater than the largest possible value in that cycle, so as to make sure that edge do not get included in the MST. Okay, so answer is option A, 69. This question belongs to computer organization subject and was asked in GATE CSE 2015. So the question states, consider a disk pack with a seek time of 4 milliseconds and a rotational speed of 1000 rotations per minute or 10,000 RPM. It has 600 sectors per track and each sector can store 512 bytes of data. Consider the file stored in a disk. So we have a disk like this with tracks and sectors, and we are storing a file on the disk. So file has 2000 sectors. Assume that every sector accesses necessities a seek. So one sector require one seek. And the average rotational latency of accessing each sector. So average rotational latency per sector equals to half of the time of one rotation. Okay, the total time to read the entire file is. Okay, so what total time will contain? So total time will be equal to, see, we have total 2000 sectors, so it will be equals to 2000 into seek time. What is the time for seeking, plus average rotational latency, plus the time to transfer the data from the file. So plus data transfer time. Okay, now see, we are not given this data transfer time. We need to calculate this. See, seek time is, what is seek time? Seek time is 4 millisecond, that we know. So it is equals to 2000 into 4 millisecond. Now we know we have 10,000 RPM, which means 10,000 rotations in 1 minute or 10,000 rotations in 60 seconds. So one rotation time equals to one rotation in 60 by 10,000 second or 6 millisecond one rotation. Okay, so what is half rotation time? 1 by 2 rotation. See, ARL, which is our ARL stands for average rotational latency time equals to half rotation. So ARL equals to half of one rotation time. One rotation is 6 milliseconds. So ARL is 3 milliseconds. So what is ARL? It's 3 milliseconds. Now we need to find what is the data transfer time. Now see, what we will assume is, since data transfer time is not given, we will assume that in one rotation all data in a track is read. One track data is read. One track data is read. Okay. So what will be your data transfer time? So one rotation takes 6 milliseconds. So one rotation. So in 6 milliseconds, we can read 600 into 512 byte data. Okay. So 512 bytes can be read in 6 by 600 millisecond or 0.01 millisecond. So it is 0.01 millisecond. So if you calculate this, then you will get 2000 into 7.01 millisecond, which is equals to 14020 millisecond. So answer is 14020 millisecond. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, compute the value of the integral from 1 by pi to 2 by pi cos 1 by x square dx. Okay. So here we will assume u equals to 1 by x. Then applying derivative on both the sides, du equals to, so what is the differentiation of this? It is x into differentiation of first minus first into differentiation of x by denominator square. So it's equals to x into 0 minus 1 by x square. So it's minus 1 by x square. So we got du by dx equals to minus 1 by x square. Now we have to change the limits. So when we were using x, then limit was 1 by pi. Now when we are using 1 by x, then limit becomes 1 by pi, which is pi. This is the lower limit. So for x, the upper limit was 2 by pi. So for 1 by x, as we have used here 1 by x, so 1 by x upper limit will become 1 by 2 by pi, which is pi by 2. So integral now changes. So the integral now is, what we have done, we have substituted u for 1 by x. So lower limit is 2 by pi, lower limit is pi, upper limit is pi by 2. Cos 1 by x is cos u, and multiplying minus on both the sides, let us see. If we do minus 1 on numerator and denominator, then it becomes minus 1 into x square dx. Now you can write minus 1 by x square. We can write du equals to minus 1 by x square dx. So minus 1 by x square dx can be written as du. So it gets converted into pi to pi by 2. This minus 1, one of the minus 1 goes with this and 1 comes over here. We have cos u and du. Now what is the integration of cos u? Cos u is sin u. So we got minus, range from pi to pi by 2, sin u, we got minus sin u with the limit from pi to pi by 2. So it becomes minus sin pi by 2 minus sin pi. What is sin pi by 2? It's 1. What is sin pi? It's 0. So it becomes equals to minus 1. So answer to this question is minus 1. It was a numerical answer type question. So answer is minus 1. This question belongs to programming subject and was asked in GATE CSE 2015. So the question states, consider the following C program segment. So this is the program for our binary search. So we have while, we have an array, we have a first and a last. So while first is less than last, we find the middle element. If array of middle is less than our source item, we increment our first to middle plus 1. Else, if we found it, we return from here, found equals to true and come out of the loop. Else, we do last equals to middle minus 1. And after coming out, we check if the item was not present, then first would have moved in front of the last, then not present equals to true. We need to tell what is the cyclometric complexity of the above segment. So what is cyclometric complexity? So it has a formula. So it states that it is number of predicates with out degree equals to 2 plus 1. Okay, so this is the formula. So for this, first we need to create the tree. So let me first create the tree for you. Let me move this over here. Yes. So how we create a tree? First we have an entry over here. So we have entry or the start of program. Okay. Then we first come to while. We have a while statement. Now this statement will either evaluate to true or false. So either it evaluates to true or it evaluates to false. If it evaluates to false, we will come out of the while loop. So we will come out of the loop. So let us write it as point P1. So we come to point P1 if it is false, like this. If it is true, then we check the if statement. If it will either evaluate to true or false. Either it will evaluate to false or to true. If this is true, then this won't execute, and we will execute this middle part. Then we will execute the middle part. So if it is true, we will come to the middle statement. Okay. Now what happens? If this if is false, then what happens? We come to else if. Else if. Either it will evaluate to false or it will evaluate to true. If it evaluates to true, again we will come to the middle part. Now we have else over here. It will evaluate to either true or false. If else evaluates to false, we will come to the middle part. And even if else evaluates to true, we will execute this and come to the middle part. Okay. Now after this middle part, we will come out of the loop and come to point P1. Now from this point P1, we will go to if. Now if will either evaluate to true or false. If it will evaluate to true or false. If it evaluates to false, we will exit the program. We will exit the program. If it evaluates to true, we will do this statement S1 and then we will do exit. Now the out degree 2. So which has out degree 2? See, while has this one out degree, this one out degree. So while has an out degree 2. If has 1 and 2, 2 out degree. Else if has 2. Else has just 1. Okay. And if has 2 for true and false. The number of predicates with out degree 2 are 1, 2, 3 and 4. So we have 4 predicates with out degree 2 and plus 1 for this. So correct answer is 5. So we have psychometric complexity of 5. This question belongs to programming subject and was asked in GATE CSE 2015. So the question states, consider the following C function. So we have a function over here. Which one of the following most closely approximates the return value of the function fn1? So fn1 is returning q. So we need to tell what is the value of q after the execution of the program. Okay. So before this, let me tell you the complexities for these two loops, for loop 1 and loop 2. So what happens in loop 1? So we are having iteration from n to 1 and j equals to j by 2 and we are incrementing p. So what happens? Initially j will be n, okay, then j will become n by 2. In the next iteration it will become n by 2 square. In the next iteration it will become n by 2 cube, then n by 2 to the power 4. Let us suppose it goes to n by 2 to the power k. It has total k iterations. So when it stops, it will stop when n by 2 to the power k become equal to approximately 1 or 2 to the power k equals to n. Applying log on both sides, we get log 2 to the power k equals to log n, or k log base 2 of 2 equals to log n, or k equals to log n, as log base e of e is 1. So log base 2 of 2 is 1. So k equals to log n, which means this loop will run log n time. So let me write over here, this loop will run log n time. Now let us analyze this for the second loop. So for the second loop, what we are doing, initially we have a value 1, so we are executing for k equals to 1. Then we multiply k by 2, so it becomes 2, then 2 square, then 2 cube, up till, let us assume, it goes till 2 to the power k, or 2 to the power l, let us assume, because k is already over here. So the value of k goes to 2 to the power l. So we have total l iterations. So when will it stop? When 2 to the power l equals to p. Applying log on both sides, l log base 2 of 2 equals to log p. So l equals to log p. So it will run log p time. It will run log p times. Now let us see what is happening. And how many times will this main loop runs? Let us take it as loop 3. So loop 3 will run for I equals to 1 to n. So it will run n times. Okay. So what happens? Suppose we have a first iteration of loop 3. First iteration of loop 3. In this, first p will be initialized to 0. Then this will run n times. So p value will become increment by 1, increment by 1. P will become equal to log n. Now this will run for log p times. So whatever q value will become, q value will become log p. So what is the q value after one iteration? Q is equals to log p. And what is the p value? P equals to log n. So putting this value over here, we get q equals to log p log n. So we get log n. Q value is log n. So what happens in the second iteration? Again p is initialized to 0. So this value, p value, will be log n. But q is not initialized anywhere. So q will start again from log p and will increment by one more log p. So what is the new q value? New q value will be 2 log p. And what is the value of log p? Log p is log n. So this is p value is log n. So after second iteration, it becomes 2 log n. After third iteration, it will become 3 log n. How many iterations do we have? We have n iterations. So after n iteration, it will become n into log n. So this will be our q value. So answer is option D, n log n. This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, let an represents the number of bit strings of length n containing two consecutive ones. What is the reference relation for an? So suppose we have a2. So a1. So a1 is number of bit strings of length 1 containing two consecutive ones. So what are all the bit strings? So all the bit strings are 0 and 1. So both of them come under a1 as no one contains two consecutive ones. What are the bit strings of length 2? It are 0, 0, 0, 1, 1, 0, 1, 1. We have to consider only one that do not contain two consecutive ones. So we do not have 1, 1. Only 3 are there. Now we have a3. So it's 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. So, okay. Actually, the question is containing two consecutive ones. So for a1, we have nothing over here. And a1 dash is this. For a2, we have just 1, 1. For a3, this is a2 dash. A1 dash means number of bit strings of length 1 not containing two consecutive ones. Not containing two consecutive ones. Bit strings of length 2. A3 dash is number of bit strings of length 3 not containing two consecutive ones. So not containing two consecutive ones. So 0, 1, 1 won't be here. It will come over here. Then we have 1, 1, 0 and 1, 1, 1. 1, 1, 0 and 1, 1, 1. Okay. 0, 0, 1, 0, 1. 1, 0, 0, 1, 0, 1. Okay. So see, how many bit strings are over here? There are 0, 1 and 3. And how many bit strings are over here? There are 2, 3 and 5. Is there any method to derive this? A and dash based on the previous value. So A4 dash, how we will do is, if we have a 0 at the last, then we can add a 0 or a 1, as both of them won't have any consecutive ones. So adding a 0, so here we add a 0 and here we add a 1 to this. Now to this, it has a 1. So if it is a 1, we add only a 0. So we will add only a 0. As if we add a 1, it will become two consecutive ones. So here we add both 1 and 0. 0 and 1. Here we add both 1 and 0. Here we add only 0. 0. Okay. So how many are there? There are 8. So can we see that there is a formula for this? Yes. We can say that an dash is based on the previous one, an minus 1 dash plus an minus 2 dash. SC. Here we have 2. Then we have 3. 2 plus 3 equals to 5. 3 plus 5 equals to 8. Next one would be 8 plus 5, 13. Next will be 13 plus 8 is 21. So it will go on like this. So it's like a recurrence relation. So the complement is a recurrence relation. This is the complement's recurrence relation. Now we need to find the recurrence relation of our actual an. So how will we do this? So for this, okay, we can use this one. So what is A3 dash? How will you find out number of elements in A3 dash? So what will be the total number of bit strings of length 3? They will be 2 to the power 3. And some come in the left, some come in the right. So number of elements in the right, can we write it like this? Like A3 dash, A3 equals to 2 to the power 3 minus A3 dash. The number of items in A3 equals to number of items in 2 to the power 3 minus A3 dash. We can verify it. Number of items in A3 is 3. 3 equals to 2 to the power 3 minus 5. So 3 equals to 8 minus 5. 3 equals to 3. So generally we can write an number of items in an equals to 2 to the power n minus number of items in an minus 1. So we will use this identity. Let me clear the stuff out. So basically we have used the first created the recurrence relation for the complement an complement. Then we use this an complement to derive the value for an. So what is an dash? An dash can be written as, and we can also write this similarly for an dash. So an dash equals to 2 to the power n minus, it's not like this, it's an. Yes. An dash equals to 2 to the power n minus an. Or we can say an equals to 2 to the power n minus an dash. Both will have the same value. As for 3, what are the an dash? They are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 1 come over here, it's an dash. So we have 1, 0, 0, 1, 0, 1, 1, 1, 0 over here, 1, 1, 1 over here. So this is 3 and this is 5. So we can write it like, we can write 5 equals to 2 to the power 2 to the power 3 minus 3, or we can write 3 equals to 2 to the power 3 minus 5. Both are same. So here both have the same meaning. Now let us write it, the recurrence relation for an based on an dash. So here we have, so an dash equals to 2 to the power n minus an equals to, what is the value for an dash n minus 1? It's 2 to the power n minus 1 minus an minus 1 plus 2 to the power n minus 2 minus an minus 2. On the same terms, we are writing this. Now, let us take an to that side, as we need to tell the value for an, and bring all of this to this side. So, with 2 to the power n minus 2 to the power n minus 1 minus 2 to the power n minus 2 plus an minus 1 plus an minus 2. Okay. Can we divide this by 2 and multiply this by 2? So, if we multiply this by 2, it becomes 2 into 2 by 2, and here we multiply it by 2 square and divide by 2 square. So we get an equals to 2 square is 4 into 2 to the power n minus 2, bringing this denominator in the numerator, minus 2 into 2 to the power n minus 2 minus 2 to the power n minus 2 plus an minus 1 plus an minus 2. So an equals to 4 minus 2 minus 1. So it's 2 to the power n minus 2. Taking as common, we get 4 minus 2 minus 1. So it's 1 only. Plus an minus 1 plus an minus 2. So answer is option A. An minus 1 plus an minus 2 plus 2 to the power n minus 2. This question belongs to compiler design subject and was asked in GATE CSE 2015. So the question states, the variable x is said to be live at a statement si in a program if the following three conditions hold simultaneously. There exists a statement sj that uses x. So x is said to be live if there is a statement sj that uses x. There is a path from si to sj in the flow graph of the program. The path has no intervening assignment to x, including at si and sj. So we have this control flow graph given below. The variables which are live both at statement in the basic block and at the statement. So we need to tell the variables which are live both at the statement in basic block 2 and the statement in the basic block 3 of the above control flow graphs are. And these are the options. So let us see how we will do this. See, the variables q and the variable r are live at the entry point of block 1. So this is a block 1. So the variables which are live over here are q as well as r. Now what about p? The variable p is dead. So what are dead variables over here? The variable p is dead. Why? Because see, here the value of p is overwritten at the first statement and the statement 2 is using the p value, but it is using the overwritten p value. Okay. Because p is overwritten at the first statement and the statement 2 of block 1 uses the new value. And from the line 2 of block 1, p is never used. So p is dead over here. So only live variables are only q and r. Okay. Now see, in case of variable s, similarly, we can see that variable s is overwritten over here and a new value of s is being used from the line 3 in block 1. So s is dead at the entry point. So s is dead over here. Okay. Now see, what about u? U is overwritten, but u is never used in block 1. So u is dead. U is also dead before block 1. Now q is done, r is done, p, s and u are done. Now what about block 2? In block 2, the variables r and u are being read. See, we are reading r and u. So they are live at the entry point. So the variables live over here are r and u as they are being used, as well as they are used in the assignment line of the block 2. Same is the case for block 3. Here variables s and u are live at the entry point of block 3. So the variables which are live are s and u. Now talking about block 4. At the entry of point of block 4, v and r are live as they are being used. So live variables are v and r. Okay. Now at the block 3, at the exit point, variable v and r are live and at the entry point they are live for the block 4. Okay. Now there is a rule for liveness analysis. Like if a block B does not use a variable v, which is live after its exit point. So let us suppose here it is like this. Here x is live and here x is live. So if in a block B does not use a variable v, which is live after its exit point, then this variable v is live also before the entry point of the block B. Okay, so we can write L Sx in equals to L Sx out if S does not refer to x. Now, since the variables v and r are live after the block 3, so after block 3, V and R are live over here. So over here we have V and R are live variables. So they must be live before the block 3. If they are live after the block 3, so they must be also live before the block 3. And V is not shown in the figure. So at the entry point of the below blocks, so at B2, at block 2, R and U are live, and at block 3, R, S, U and V are live. See, S and U are live, but because of this condition. Which condition? There is a condition which says that if a block B does not use a variable V, so here V and R are not used, which is live after its exit, and it's live after its exit, then the variable V is also live before the entry. So here also V and R would be live if they are live afterwards and they are not used in between. Okay, so V and R also come over here. So what is the common variables in both these? What is the intersection? Their intersection is R and U. So answer is R and U, option C. This question belongs to operating system subject and was asked in GATE CSE 2015. So the question states, consider a uniprocessor system. So we have only one processor, CPU, executing three tasks T1, T2 and T3. So we have T1, we have T2 and we have T3. Each of which is composed of infinite sequence of jobs. So it is an queue or a sequence of jobs. It is an infinite queue, which means jobs keeps on coming, which arrive periodically at the intervals of 3, 7 and 20 milliseconds. So it arrives at period of 3 milliseconds, it at 7 and it at 20 milliseconds. The priority of each task is the inverse of its period. So what is its priority? Its priority is 1 by 3, its priority is 1 by 7 and its priority is 1 by 20. Now it says, and the available tasks are scheduled in order of priority, which is the highest priority task scheduled first, which means T1 will be has more priority than T2, which has more priority than T3. Each instance of T1, T2 and T3 requires an execution time of 1, 2 and 4 milliseconds. Okay. So here we can write execution time as priorities I have written over above. So they have execution time of 1 millisecond, it has 2 milliseconds and it has 4 milliseconds. Given all the tasks initially arrive at the beginning of the first millisecond and the task preemptions are allowed. So preemption is preemptive, preemption is allowed. The first instance of T3 completes its execution at the end of dash millisecond. Okay, so we need to tell when first instance of T3 completes its execution. So see, T1, T2 and T3 have infinite instances, meaning infinite burst times. Here the problem say that we have to run T1 for 1 millisecond, T2 for 2 millisecond and T3 for 4 millisecond, which means each task run in parts. Okay, now let us see when will a new instance of a particular task comes. So as T1 repeats after T1 comes at first instance at 0th millisecond, so it repeats after 0, 3, 6, 9, 12, infinite. Okay, because it has a period of 3. T2 repeats after 0, 7, 14, 21 and so on up till infinity, as its period is 7. And similarly for T3 we get 0, 20, 40, 60 up till infinity. And they have a priorities of 1 by 3, 1 by 7 and 1 by 20. So T1 has more priority than T2 than T3. So here priority goes on like this. Priority. Okay. Now let us draw the Gantt chart for this. So Gantt chart looks like this. Here let me write the time over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So initially, what is given? It is given that none of the process arrive at 0 millisecond, and all of them arrives at first millisecond. It's given over here. Each instance given all the tasks arrive at the beginning of the first millisecond. So all of them arrive over here. So at t equals to 0, no process was available. And at t equals to 1, we have t1, t2, t3. Here we have t1, t2 and t3. As t1 has more priority, so we will schedule t1 over here. So here t1 gets completed and we have only t2 and t3. Okay, so now what happens? So at t equals to 2, T2 will run because T2 has more priority than T3 and no instance of T1 is present. So T2 will run over here. Now what happens? Here we have only T2 and T3 available. So again T2 will run and there will be no preemption. Okay. Now what happens? At T equals to 4, T2 gets completed, T1 has already completed. So here we have only T3. But T1 arrives again. It arrived at 1, so now it arrived at 4. So it is 0 based indexing, but in this question it is given that everyone arrives first at 1. So at 1, then 4, then 7, then 10, then 13, then 16. T2 arrives at 1, 8, 15, 22. T3 arrives at 1, 21, 41, 61, and so on up to the infinity. So what happens at t equals to 4? T1 again arrives and T2 has completed and T3 is present. So T1 will get executed as it has more priority. Now what happens over here? At 5, T3 is present only as no instance of T1 or T2 is here. So T3 will execute over here. Now what happens over here? Here we have just T3. So T3 will execute over here. Now what happens at t equals to 7? At t equals to 7 we get T1, T3 is present, and then we get, so how T3 which is running initially at 4 burst time, but 2 of them get completed, so we have 2 burst time. So at t equals to 7 we have T1, T3. So what executes? T1 executes and gets completed over here. So here we have partial T3. This means partial T3. T3. We have partial T3 and then T2 also arrives. So at t equals to 8 we get T2. So T2 executes over here. Here we have partial T2. At 9 we have partial T2 as well as partial T3. T2 has more priority, so at t equal to 9 T2 gets executed. So T2 completes and we have only partial T3 over here, and at t equals to 10 T1 also arrives. So at t equals to 10 T1 will execute and will get complete over here, and so here we have only partial T3. So what happens? Here T2 is going to arrive at 15, not yet arrived. T1 is going to arrive at 13, not yet arrived. So T3 will execute over here. 1 burst time is left. Now at t equals to 12 only T3 is present. So T3 will execute. 0 burst time left, which means all of them executed. So now at t equals to 13, what all we have? T3 is executed. So we have T1, only T1, so T1 will execute. So we need to tell at what time T3 completes its execution. So T3 completed its execution over here. So at the end of 12th millisecond, T3 completed its execution. So answer is 12 milliseconds. This question belongs to Database Management System subject and was asked in GATE CSE 2015. So the question states, consider the following relation. So we have a student relation and a performance relation, where student relation has roll number as the key attribute and student name, performance has roll number and course as the key attributes, and marks is also an attribute but not key. Now the relation states select s dot student name, sum p dot marks from student as s, performance as p, where s dot roll number equals to p dot roll number, grouped by s dot student underscore name. The number of rows that will be returned by the SQL query is. Okay, so let us analyze what it is doing. So here it is selecting two attributes from student S and performance P. This is a cross product. So a cross product will be done. So what all fields will be there? We will have student is renamed as S. So we will have S dot roll number. We will have S dot student name. We will have P dot roll number. We will have P dot course. We will have P dot marks. Now it will have all entries. Like cross product will have all the possible entries. Here there are 3 and here there are 6. So each one will be 3 into 6. We will get 18 entries. Which means this one Raj will be mapped to all these. One math 80. One Raj will be mapped to one English 70 up till one Raj will be mapped to 3 math 80. Then again same thing will go for 2 Rohit. 2 Rohit will start the mapping from 1 math 80 go till 3 math 80 and then again Raj will start it mapping. But then we have a condition where S dot roll number equals to P dot roll number. So here we will remove the entries like this. As here S dot roll number is 1, P dot roll number is 3, here it is 2, here it is 1 and we will have equal entries like this, like 1 equals 1, 1 equals 1. So what all entries will be there? Which have only similar roll number values. So let us see what are those entries. So we have one Raj. So one Raj will be mapped, will have only entries with a 1. So we will have one math 80, one Raj with one English 70. Then we will have one is not in any roll number, so none of them will come. Then we will have 2 Rohit. It will map to only 2 entries. So we will have 2 math 75. It will map to 3 English. Only to 2 physics. 2 physics 65. Here we have 2 Rohit. Okay, then we have an entry with 3. So we have 3 Raj. It will get mapped to 3 English 80 and 3 Raj will get mapped to 3 math 80. Okay, so we will have only 6 entries. Now we have group by. So group by student name. So similar student names will be merged. Here we will merge this. And then, so what happens after merging? So one Raj and one Raj will be merged. And how these entries will be merged? So see, the output has only s dot student underscore name and sum of p dot marks after merging. So what happens is that we have to merge. See, we are merging Raj. So same name will be there, same roll number will be there. Now, what will be the student name? It will be Raj. We will have sum of p dot marks. So these marks will get added up. And here also Raj is there. Roll number is different, but we are combining by the name. So both of them, all 4 will get combined. Roll numbers are different, it doesn't matter. So we will have Raj and sum of these marks. So 80 plus 70 plus 80 plus 80. So it's 8, 16, 24, 240 plus 70. It's 310. Okay, then we will have Rohit. So in case of Rohit, both these entries will get merged. We will have marks equals to, it's 140. Now it's asking the number of rows that will be returned by the SQL query. So we have only 2 rows. So answer is 2. This question belongs to Digital Logic Design subject and was asked in GATE CSE 2015. So the question states, a positive S triggers D flip-flop is connected to a positive S trigger JK flip-flop. So we have a D flip-flop connected to a JK flip-flop. The output of the D flip-flop is connected to both J and K inputs of the Q JK flip-flop. So output is connected to both J and K inputs, while the Q output of the JK flip-flop is connected to the input of the D flip-flop. So we have output connected to the input of the D flip-flop. Initially, let us assume this is Q1, this is Q2. Initially, the output of D flip-flop is set to logic 1. So initially D is 1, this means Q1 is 1, and the output of JK flip-flop is cleared, which means Q2 equals to 0 initially. Which one of the following is the bit sequence including the initial state generated at the Q output of the JK flip-flop when the flip-flops are connected to free running common clock? So we have a common clock connected to both the flip-flops. Assume that J equals to K equals to 1 is in the toggle mode. So J equals to K equals to 1 means toggle, and J equals to K equal to 0 means state hold, which means previous state equals to next state of the JK flip-flop. Both the flip-flop have non-zero propagation delays. Okay, so what happens now? So what is the next state of Q1? What is Q1 plus? We know next state for a D flip-flop equals to D. So Q1 plus equals to D. And what is the value of D? D equals to the output of the JK flip-flop. So it's equals to Q2. So Q1 plus, we can write Q1 plus equals to Q2. Now what is Q2 plus? So for a J flip-flop, it goes on, we have an equation, characteristic equation is J Q1 complement plus K complement Q1. Now if we write the values of J, so J equals to Q1 and K equals to Q1. So we get Q1 Q2 complement plus Q1 complement Q2. So Q2 plus equals to, it's the equation for XOR. So it's equals to Q1 XOR Q2. So this is one equation, this is second equation. Now let us draw the truth table. So we have Q1, Q2, Q1 plus whose value equals to Q2, and Q2 plus whose value equals to Q1 XOR Q2. Okay. So what is the initial value of Q1? Q1 is 1 initially given. Q2 is 0 initially given. Now what is Q1 plus? It's equals to Q2, which is 0. This will be transferred here. What is Q2 plus? It's Q1 XOR Q2. This will be transferred here. So 1 XOR 0 is 1. Now what is Q1? Next state Q1. So next state Q1 will be equals to, this will be transferred over here. So Q1 plus will become Q1. So we will have 0. Q2 plus will become Q2. We will have 1. Now this will be transferred over here, and both these XOR. 0 XOR 1 is 1. Now we will have 1 1 over here, 1 over here, and 1 over here. 1 transferred over here. 1 XOR 1 is 0. Now we have 1 over here, 0 over here, 0 transferred over here, and we have 1 XOR 0 is 1. Now let us try to match which of the following options are matching. So initially, what was the output? Initial output was 0. It is given initial output was 0. Now let us do one more iteration. So we have 0 over here, 1 over here, 1 transferred over here, 0 XOR 1 is 1. So this is our output state. It's 0 1 1 0 1 1. So answer is option A, 0 1 1 0 1 1. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, let G be a connected planar graph with 10 vertices. So number of vertices n equals to 10. If the number of edges on each face is 3. So for each face we have 3 edges. The number of edges is, now suppose this is a face and this is a face. So what are the number of edges? So if in each face we are having 3 edges, the number of edges equals to 3 times the number of face. But each edge will corresponding to 2 faces, like each edge over here will correspond to 2 faces. So it will be double counted. So number of edges equals to 3f by 2. Now according to Euler's formula we have, so what is Euler formula? Euler formula for connected planar graph. It's equals to n minus e plus f equals to 2, where f is the number of faces, e is the number of edges, and n is the number of vertices. So n is 10, e is 3f by 2. How we got this? Because each face has 3 edges and each edge corresponds to 2 faces. Plus f equals to 2, 10 minus f by 2 equals to 2, f by 2 equals to 8, or we can say f equals to 16. So what is the value of e equals to 3 by 2 into f? What is f? 16. So we got 48 by 2, which is 24. So answer is 24. This question belongs to computer network subject and was asked in GATE CSC 2015. So it states, consider a LAN with 4 nodes. So we have S1, S2, S3 and S4. Time is divided into fixed size slots and a node can begin its transmission only at beginning of a slot. So we have certain slots and a node can begin, this is our timeline, and a node can begin transmission only at beginning of a slot. The probabilities of generating a frame in a slot by S1, S2, S3 and S4 are 0.1, 0.2, 0.3, 0.4. So our probability of generation is this. So probability of not generating is Pg dash is 1 minus Pg, which is 0.9, 0.8, 0.7 and 0.6. The probability of sending a frame in the first slot without any collision by any of these 4 stations is. So we need to tell what is the probability that here any of them will be able to send the frame without any collision. So probability of sending means either S1 will be able to send, or S2 will be able to send, or S3 will be able to send, or S4 will be able to send. Okay, now if S1 is sending, then S2 and S3 won't send. So if S1 is sending, then S2, S3, S4 won't send. Or if S2 is sending, then S3, S4, S1 won't send. Or if S3 is sending, then others 3 won't send. Or none of them will send, only the last one will send. So we have to sum it up. So P of S1 means S1 is sending with a probability 0.1 and all 3 are not sending with probability 0.8, 0.7 and 0.6. Plus S2 is sending means it is sending with a probability of 0.2 and others are not sending with probability 0.9, 0.7 and 0.6. S3 is sending means it's sending with a probability 0.3 and others are not sending with probability 0.9, 0.8 and 0.6. S4 is sending, which means it is sending with a probability of 0.4 and others are not sending with probability 0.9, 0.8 and 0.7. So probability of at least one is sending and is exactly one is sending without any collision in the first time frame is, if you sum it up, you will get 0.4404. So answer is 0.4404. This question belongs to operating system subject and was asked in GATE CSC 2015. So the question states, suppose the following disk request sequence track numbers for a disk with 100 tracks are given. So we have a disk with 100 tracks, 1 up till 100, and it has these requests. So let me first plot this request. So we have 50, 45, 20, we have 10, 20, 90, 80, 70, 60, 1, 2, 3, 4, 5, 6, 7, 8. 1 is left, 45 is done, 20 is done, 90 is done, 10 is done, 50 is done, 60 is done, 80 is, we have at 25. Okay. Assume that initial read-write position of read-write head is on track 50. So initial read-write header is at track 50. The additional distance that will be traversed by read-write head when SSTF is used compared to scan or elevator. So we have to find the value of SSTF minus scan. Number of scans it need to make to the track. Assuming scan move towards 100. So scan move towards 100. So first let us do for SSTF. So we are at 50. Shortest seek time first, which means we have to go to the shortest track first, shortest request we need to satisfy first. So either we have option to satisfy 45 with a distance of 5 or a 60 with a distance of 10. So we will satisfy 45. Now either we can satisfy 25 with a distance of 20 or 60 with a distance of 15. So we will satisfy 60, then we will prefer 70 over 25, 80 over 25, 90 over 25. Then we have no option other than going to 25, 20 and 10. So SSTF takes total time 5 over here, 90 minus 45 is 45, 90 minus 10 is 80. So we got 80 plus 50, which is 30. Now let us do elevator elbow. So what elevator elbow does is that it is given that it goes towards 100. So it satisfies all the requests while going towards 100. Then it comes back and satisfies 45, 25, 20 and 10. So scan elbow takes 50 up till 100 is 50, 100 minus 10 is 90. So it takes total 140 and over here 130. So what is scan minus SSTF or SSTF minus scan? It's given that SSTF takes more time, so scan minus SSTF is 140 minus 130, which is 10. So answer is trend tracks. This question belongs to computer network subject and was asked in GATE CSE 2015. So the question states, suppose that stop and wait protocol is used for a link with a bit rate of 64 kilobits per second. So bit rate is 64 kbps and 20 milliseconds propagation delay. So TP equals to 20 milliseconds. Assume that the transmission time for the acknowledgement and the processing time at nodes are negligible. Then the minimum frame size in bytes. So we need to tell what is the frame size. Frame size in bytes. To achieve a link utilization of at least 50% is. So how we do this? So for a stop and wait protocol, we first transmit the entire data, wait for it to reach to the destination, wait for the acknowledgement to come back, and after that we will transfer the next data. So suppose we have a transmission time of TT and a propagation time TP over here, TP over here. So we have 2 TP. We have total this time, but in this we are only utilizing the TT time for transmission. So efficiency equals to TT upon TT plus 2 TP. So what is TT? TT is transmission time. So suppose we have a frame of size F bits. We have a frame of size F bits and bit rate is 64 kbps. So what is transmission time? It's F by 64 kilo. So if we have F bits and we have 64 kbps. So we have F by 64 kilo. Here it's F by 64k plus 2 TP. What is the value of TP? TP is 20 millisecond or 20 into 10 to the power minus 3 second. So we get efficiency as 1 by 2 or 50 by 100. So here it is 50 upon 100. We get 1 by 2 equals to F by 64 into 10 to the power minus 3 divided by F by 64 into 10 to the power minus 3 plus 40 into 10 to the power minus 3. These 10 to the power minus 3's gets cancelled. So we get F by 64. Using cross multiplication, we get F by 64 plus 40 equals to 2F by 64. Or we get F by 64 equals to 40. Or we can say that what is the value of, if we get F by 64 as 40, then F equals to 2560 bits. So F is 2560 bits. We need to tell in bytes. So number of bytes is 2560 by 8. So we get it equal to 320 bytes. So answer is 320. This question belongs to operating system subject and was asked in GATE CSE 2015. So the question states, consider a main memory with 5 page frames and the following sequence of page references. So we have this reference string given here. Which one of the following is true with respect to page replacement policies, first in first out FIFO and least recently used LRU? Both incur the same number of page faults. FIFO incurred 2 more page faults than LRU. LRU incurred 2 more page faults than FIFO. FIFO incurs 1 more page fault than LRU. So we need to compare FIFO as well as LRU. Okay. So we have 5 page frames. So let us make them. So it's first frame, second frame, third frame, fourth frame, and fifth frame. So we have F1, F2, F3, F4, and F5. And we get request for the frames. So let us write the request over here. The request we are getting are 3. Let me write it over here. 3, 8, 2, 3, 9, 1, 6, 3, 8, 2, 3, 9, 1, 6, 3, 8, 9, 3. Then we have 6, 2, 1, 3, 3. Then 6, then 2, 1, 3. Okay. And here tick means a hit and cross means a miss. So, and we are writing it first for FIFO. So what happens in FIFO? So in FIFO we will get 3. So 3 is present? No. So we will have a miss and 3 will be brought. Okay. FIFO means the one which came first will be removed first in case all the frames get filled. Now 8 comes. So 8 is not present, so it will be a miss. Now 2 comes. 2 will be a miss and will be brought to the frame. Now 3 is a hit. Okay. So 3 is a hit. Now 9. 9 is a miss. 2, 9. 9 is brought. Now 1. 1 is a miss. So we get 3, 8, 2, 9, 1 with a miss. Now 6. 6 is a miss. So first in, first out. So 3 will be removed and 6 will be brought over here. 6, 8, 2, 9, 1. And it was a miss. Okay. Now we have 3. 3 is again a miss. So next is 8. 8 should be removed now. So 8 is removed and 3 is brought over here and we have 2, 9, 1. It was a miss. 8. 8 is again a miss. So we replace 2 with 8 and we have 3, 6, 9 and 1. Now 9. 9 is a hit. So 9 is a hit. We have 6, 3, 8, 9, 1. Now 3. 3 is also a hit. So we had 6, 3, 8, 9, 1. Now 6. 6 is also a hit. 6, 3, 8, 9, 1. Then we have 2. 2 is a miss. So 9 is replaced with 2. 3, 6. It was a miss. Now 1. 1 is a hit. So we get 1 as a hit. 6, 3, 8, 2, 1 with a hit. Now 3. 3 is also a hit. So we get 1, 2, 8, 3, 6. So how many hits are there? There are 1, 2, 3, 4, 5, 6. We have 6 hits. And how many miss? 1, 2, 3, 4, 5, 6, 7, 8, 9 misses. We have 9 miss. Total of 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, perfect. Now we will write it for the second one. So for the second one, so remember this, we have 6 hit and 9 miss. Okay. Now let us do it for the second one. So we had 6 hits and 9 misses. Now let us do for LRU. So what happens in LRU? In LRU we will replace the frame which is least recently used. So 3 is a miss. Okay. 8 is a miss. Okay. 2 is a miss. Yes. 3 is a hit. Yes. 9 is a miss. Yes. 1 is a miss. Yes. Now 6. 6 is not present over here. It's a miss. But frames are filled. So we will remove the least recently used. So least recently used among 3, 8, 2, 9 and 1 are 1 over here, 9 over here, 3 over here, 2 over here. It's 8. So 8 will be replaced with 6. We have 3, 2, 9. It was a miss. Now we have a 3. 3 is a hit. 3, 6, 2, 9, 1. 8. 8 is a miss. So 8 is a miss. We are over here. So among 36291, which is the least recent. So we have 3619. So 2 is the least recent. So 2 will be replaced by 8. It was a miss. Now we have 9. 9 is a hit. So we have 19863. It's a hit. Now we have 3. 3 is a hit. We have 36891. Now we have 6. 6 is a hit. We have 36891 with a hit. Now we have 2. 2 is a miss. So among 36891, which is the least recently used, 6398. So 1 is the least recently used. 1 is replaced with 2, and it was a miss. Now 1. 1 is a miss. So among 36892, which is the least recently used, 26398. So 8 is least recently used. It is replaced by 1. It's a miss. Now 3. 3 is a hit. So we get 36192 with a hit. So how many hits? 1, 2, 3, 4, 5, 6 hits. So we have 6 hits and 9 misses. 1, 2, 3, 4, 5, 6, 7, 8, 9. So both incur the same number of page faults. So how many page faults are there? 6 page faults are there. Sorry, 9 page faults are there. Page fault equals to misses when page was not present. So 9 page fault in this, 9 in this. So both incur the same number of page faults. Answer is option A. This question belongs to engineering mathematics and was asked in GATE CSE 2015. So the question states, consider the operations f x comma y comma z equals to x complement yz plus xy dash plus y dash z dash, and g x comma y comma z equals to x complement yz plus x complement yz complement plus xy. Which of the following is correct? Both f and g are functionally complete. Only f is functionally complete. Only g is functionally complete. Neither f nor g is functionally complete. So we can say that an operation is functionally complete if it can derive all logic gates. So which of the functions are functionally complete? So an operation is functionally the following gates are functionally complete. We have AND, OR, NOT. This set is functionally complete. Even the AND set, and NOT set is functionally complete. Even the or NOT set is functionally complete. So if we are able to using f, if we are able to derive any of the following set, then f will become functionally complete. And if using g, we are able to derive any of the set, then g will become functionally complete. Okay, let us see. We have f x comma y comma z equals to x complement yz plus xy dash plus y complement z complement. So if we take f x comma 1 comma 1, so what happens? We have x complement into 1 plus x into 1 complement is 0 plus 1 complement is 0, 1 complement is 0. So we get equals to x complement. So we have done the NOT gate. Now let us see if we have x complement 1 and z, then what happens? X complement, we get x complements complement, y is 1, z is z, plus x complement, y is 1, 1 complement is 0, plus y is 1, 1 complement is 0 into z complement. So we get equals to xz. So we are able to do AND gate. Now we have, if we have take x as x, y as 0 and z as z complement, then what happens? We have x complement into 0 into z complement plus x as x, y as 0 complement is 1 plus y is 0, 0 complement is 1, z complement whole complement. So we get x complement, z complement. So this becomes 0. So we get x plus z. So we are able to do OR gate. So we have done this complete set. So f is functionally complete. F is functionally complete. Let us try to do it for g. So which means using the operation f, we can derive any of the gates. So g is g x comma y comma z is x complement yz plus x complement yz complement plus xy. Let us try to simplify it. Taking y as common, we get x complement z plus x complement z complement plus x. Now we have taking x complement is common, we get z plus z complement plus x. So a plus a complement is always 1. So we get y x complement into 1 plus x. And x plus x complement is always 1, so we get y. So what happens? Suppose we will use g x y complement z complement. Then we will be able to derive y complement. So we are able to derive the complement. We can do complement, but we can't do and or. And even we can't do either only and or only or. So G is not functionally complete. So answer is option B. Only F is functionally complete, not G. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So we need to find the value of this definite integral. X equals to 1 to 99, 1 upon x into x plus 1. So let us put value 1. So we got 1 into 1 plus 1 is 2 plus 1 upon 2 into 2 plus 1 is 3 plus 1 upon 3 into 3 plus 1 is 4 up till let us put 99. 1 upon 99 into 99 plus 1 is 100. Then how can we write 1 by 2? We can write it as 1 minus 1 by 2. Then how can we write 1 by 6? We can write it as 1 by 2 minus 1 by 3. As taking LCM 3. So what is 1 by 2 minus 1 by 3? We have 6 as LCM, 3 minus 2, so we get 1 by 6. And we can write 1 by 3 into 4 as 1 by 3 minus 1 by 4. Similarly, we can write it as 1 by 99 minus 1 by 100. So this will cancel this will cancel this will cancel the next one, and everything will be cancelled. We will be left only with 1 minus 1 by 100. It is equals to 100 minus 1 by 100, which is 99 by 100, which is equals to 0.99. So answer is 0.99.
This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, limit x tends to infinity, x raised to the power 1 by x is infinity, 0, 1 or not defined. Let us see. So the expression is limit x raised to the infinity, x tends to infinity, x raised to the power 1 by x. So applying exponentiation of logarithm, we apply exponentiation of logarithm. So let us take the limit out. We have limit x tends to infinity, exponentiation of logarithm of x raised to the power 1 by x. Okay, now what is log a raised to the power b? It is equivalent to b log a, which means powers come downward. So this can be written equivalent to limit x tends to infinity 1 by x. We have exponentiation of 1 by x log x. Now exponentiation is a constant function, so it can be brought outwards. So it is exponentiation of limit x tends to infinity log x upon x. See, the graph for x looks something like this. This is x. And the graph for log x looks something like this. So log x is a slow growing function and x is a fast growing function. So at a value infinity, x will have a very high value and log x will have a very low value. So what will be log x upon x? It will be almost equivalent to 0. So we have exponentiation of limit x to infinity log x upon x is equivalent to 0 at x tends to infinity. So we have exponentiation of 0, which is equal to e raised to the power 0. Anything raised to the power 0 is 1. So answer is option C, 1.
This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, which of the following are correct in order traversal sequence of a binary search trees? The sequence are, first is 3, 5, 7, 8, 15, 19, 25. Second is 5, 8, 9, 12, 10, 15, 25. Third is 2, 4, 2, 7, 10, 8, 14, 16, 20. And fourth one is 4, 6, 7, 9, 18, 20 and 25. Options are 1 and 4 only, 2 and 3 only, 2 and 4 only, and 2 only. So what is a BST? A BST is a binary tree. Binary tree means it can have at most 2 children. So this one is a BST. Yes, as it is a binary tree, and for that every node, if it is a value x, then all the childs on its left should be less than x, and on its right should be more than x. So here everything should be less than 10, and here everything should be more than 10. So example of a BST is 12 over here, 8 over here, 3 over here, 5 over here. Not 5, it should be 9 over here. Yes, see, 10. 8 is less than 10, 3 is less than 10, 9 is less than 10. 12 is more than 10. 3 is less than 8 and 9 is more than 8. So this is a BST. So what is in order traversal? First we go to the left subtree, then we go to the node, and then we go to the right subtree. So first we come to left subtree, then again here left subtree. So we have 3, 8, 9, 10 and 12. There is a property that the in order traversal of BST is always a sorted order. So anything which is sorted is the in order traversal of a BST. Let us see. 3, 5, 7, 8, 15, 19, 25. It is sorted. 5, 8, 9, 12, 10. No. 10 is less than 12. So it's not sorted. 2, 7, 10, 8. No, it's not sorted. 10 and 8. Then we have 4, 6, 7, 9, 18, 20, 25. Yes, this looks sorted. We have 4, 6, 7, 9, 18, 20, 25. Yes. So 1 and 4 are sorted. So answer is 1 and 4, option A. This question belongs to operating system subject and was asked in GATE CSE 2015. So the question states, consider a system with byte addressable memory, 32-bit logical address, 4 KB page size, and page table entries of 4 byte each. The size of page table in the system is in megabytes. So our CPU generates a logical address. It is of size 32 bits. So it is basically used to address the entire process. So what is our process size? Our process size is 2 to the power 32 bytes, which is equal to 2 to the power of logical address. So this is our process size. Now process is divided into page. So what is our page size? Page size is 4 KB. 4 KB is the page size, or it can be written as 2 to the power 2 into 2 to the power 10 bytes, which is equal to 2 to the power 12 bytes. So if 2 to the power 12 is the size of one page and 2 to the power 32 is the size of the entire process, then the number of pages can be find out as process size by page size. It equals to 2 to the power 32 divided by 2 to the power 12. The number of pages equals to 2 to the power 32 divided by 2 to the power 12, which is equals to 2 to the power 20 pages. Now we need, in a page table, we need an entry for each page. So what is our entry size? We have 4 byte for an entry size, and we need an entry for each page. The size of page table size is equals to page table entry size into number of entries. So what is page table entry size? It's 4 byte. Number of entries is 2 to the power 20. As number of pages are 2 to the power 20, and each page has one entry, so it is equals to it is 1 mega and it is 4, so it is equals to 4 megabyte. So the answer is 4 megabyte, option B. This question belongs to discrete mathematics and was asked in GATE CSE 2015, set 1. So the question states, which one of the following is not equivalent to P double implies Q? So what is the meaning of P double implies Q? Let us see the options. So these are negation of P or Q and P or negation of Q. Negation of P or Q and Q implies P. Negation of P and Q or P and negation of Q. Negation of P and negation of Q or P and Q. So what is the formula for P implies Q? P implies Q is equivalent to negation of P or Q. Or let us write it in generic way. What is X implies Y? So X implies Y is equivalent to negation of X or Y. So let us see, we have P double implies Q. So it is equivalent to, it means P implies Q as well as Q implies P. Now let us solve this one using this formula. So we get negation of P or Q and Q implies P. Let us see the options. Yes, option B is matching. Now we have, so option B is matching. Now let us try to also evaluate the second part. So what is Q implies P? According to the same formula, it will be negation of Q or P. Let us see if anything is matching or not. And it is commutative operation, or is commutative. So we can write it as P or negation of Q, which means A or B is equivalent to B or A. So we have negation of P or Q and P or negation of Q. So option A is matching. Now let us do the multiplication and try to solve it further. So we have negation of P and P. Then we have and negation of P. Sorry, we have negation of P dot P. Then we have or negation of P dot negation of Q. Then we have or Q dot P. Then we have or Q and P over here, this over here, or Q and negation of Q. So what is A and negation of A? A and negation of A is equivalent to 0. So P and negation of P cancels out, Q and negation of Q cancels out. So we get negation of P and negation of Q, or Q and P. And is also commutative, we can write P and Q. So what we get is any option matching? Yes, we have option D matching, negation of P and negation of Q, or P and Q. So which of the following is not equivalent? So C is not equivalent. So answer is option C. This question belongs to software engineering subject and was asked in GATE CSE 2015. So the question states, which of the following statements is are false? So we have XML. So what is XML? XML is extensible markup language. And we have HTML. What is HTML? HTML is hypertext markup language. They are basically used to design the web pages. So we have XML overcomes the limitation in HTML to support a structured way of organizing content. Yes, this is true. XML is basically a structured way of organizing content. XML specification is not case sensitive while HTML is case sensitive. No, this is false. Actually, XML is case sensitive while HTML is not case sensitive. So this is false. Now we have XML supports user-defined tags while HTML uses predefined tags. Yes, XML can have user-defined tags while in HTML we can use only the predefined tags. So this is true. XML tags need not be closed while HTML tags must be closed. No, this is false. Why? Because we have some HTML tags that need not be closed, like image tag, HR tag, BR tag, and many more. So HTML tags need not be closed. They need not be closed, and XML tags must be closed. So the things that are false are option 4 and option 2. So 2 and 4 are false. So answer is option C. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, for a set A, the power set of A is denoted by 2 to the power A. So what is power set? Power set is basically a set containing all the possible subsets. So it is a set of all possible subsets of A. If A equals to 5, 6, 7, then which of the following options is are true? Okay, let us see the options. So we have phi is a subset of 2 to the power A. We know phi is a subset of every set. Phi is subset of every set. Since A is a set, thus collection of all its subsets, which means 2 to the power A is also a set, and phi will be a subset of both A as well as 2 to the power A. So second one is true. Now let us draw the set 2 to the power A. It will contain all the subsets of A. So we will have phi, then we will have 5, we will have 6, we will have 7. Oh, sorry, there is a mistake over here. It is 7. Then we will have 5 as well as 6. Then we will have 5 as well as 7. Then we will have 6. as well as 7. Then we will have all 5, 6 and 7. So number of items are 1, 2, 3, 4, 5, 6, 7, 8, 9, which is equals to either this can come or this can come or this can come. So if a set has number of elements as this, then the power set is 1, 2, 3, 4, 5, 6, 7, 8, 2 to the power n. So for a set of n items, if cardinality of A is n, then cardinality of 2 to the power A is 2 to the power n. Now let us see. 5 belongs to 2 to the power A. Yes, 5 is over here. So 5 belongs to 2 to the power A. Okay. 5, comma 6 belongs to 2 to the power A. So for this entire thing should be inside an element of this. Okay. Is it possible? Yes. Here, see. 5, comma 6 is an element. So option 3 is also true. Now we have 5, comma 6 is a subset of A. For this, 5, comma 6 should belongs to 2 to the power A. But we can see nothing like this belongs to 2 to the power A. Only this bracket should be there, belongs to 2 to the power A, but not 5, comma 6. Thus, option 4 is false. So answer is option 1, 2 and 3. So option C is correct. This question belongs to computer network subject and was asked in GATE CSE 2015. So the question states, in one of the pair of protocols given below, both the protocols can use multiple TCP connections between the same client and the server. Which one is that? Okay, so what is HTTP used for? HTTP basically stands for, it is basically used for getting our web pages. Okay, so we can have multiple TCP connections for HTTP because it might be possible that in a web page we may have some data and we may have some images. So we can use different TCP connections for each of the image. So HTTP can have multiple TCP connections. It can have multiple TCP connections. Now let us see FTP. FTP is basically used for file. Before this, let me tell you Telnet. So Telnet is basically used for remote login. Here we will use, like you might have seen AnyDesk. So these are remote login softwares. So they used only single TCP connection. So only one TCP connection. FTP is used for file transfer, like exchanging the file on different systems. So FTP will use two TCP connections. Second connection will be based on Telnet. It will be used for data transfer. And the first connection will be used for control information, like what action we want to perform. It is also a TCP connection. So here we have two TCP connections. So FTP also has multiple TCP connections. Then we have SMTP. SMTP is basically used for simple mail transfer protocol. It is used for transferring the mail, sending mails, like we have mail agents and mail servers and we send the mail using them. It also uses a single TCP connection. One TCP connection, one TCP connection. It has multiple TCP connections and multiple TCP connections. So it is asking for which can use multiple TCP connections. So answer is HTTP and FTP. So option A is correct. This question belongs to computer network subject and was asked in GATE CSE 2015. So the question states, suppose that everyone in a group of n people wants to communicate secretly with n-1 others using symmetric key cryptographic system. So we have n people in a group like this, and every person wants to communicate with every other person. So this person 1 wants to communicate to 2, 3, 4, 5 as well as 6. So 1 wants to communicate to everyone. Similarly, 2 also wants to communicate with 3 as well as with 4, with 5 and 6. 3 also wants to communicate with 4, 5 and 6. 4 wants to communicate with 5 and 6. And 5 also wants to communicate with all 1, 2, 3, 4, 5 and 6. We are using symmetric method. So symmetric method means if we have a client and a server or two machines, then we will use only one key. One key. The same key is used for encryption and decryption. The communication between any two persons should not be decoded by others in the group. So we must ensure confidentiality. The number of keys required in the system as a whole to satisfy confidentiality requirement is okay. So suppose we have n people. 1, 2, 3, 4, 5, 6 up till n. So for each connection we will need one key. So 1 with 2 will need one key, with 3 will need another key, with 4 will need another key, with 5, with 6 up till n. So number of keys required by person 1 will be n-1. Now second person need to communicate with 1, but it has already this key, so it just need key for 3, 4, 5 and so on up till n. So second person needs n minus 2 keys. Similarly, third person already has key exchange with 2 and 1, so it needs key with 4 up till n, so it needs n minus 3 keys. In similar way, the last person, the nth person, n minus 1 person will need only one key with the nth person, so it will need only one key. So total keys required are n minus 1 plus n minus 2 plus n minus 3 up till 1. So it is nothing but it is an AP from 1 to n minus 1. So the 1 plus 2 plus 3 up till x. So what is it equivalent to? It is equal to x into x plus 1 by 2. It is the sum of x items. So it is equals to x, which is n minus 1 into n minus 1 plus 1 by 2. So it is equals to n into n minus 1 by 2. So answer is option C. This question belongs to algorithm subject and was asked in GATE CSC Set 1 2015. So the question states, which of the following are the worst case complexities of insertion and deletion of a key in binary search tree? Order of log n for both insertion and deletion, order of n for both insertion and deletion, order of n for insertion and log n for deletion, theta of log n for insertion and theta of log n for deletion. So these are theta symbols. So what is a BST? In BST, for every node, BST is basically a binary tree with a condition that everything on the left is less than x and everything on the right is more than x. So let us take an example. If we have 100, then everything on the left should be less and everything on the right should be more. It is basically a binary tree. A binary tree means each node can have at max 2 children, 0 child, 1 child or 2 child. So it is 100, so it should be less than 100. Let us suppose 50, it should be less than 50, like 40, more than 50 but less than 100, 70. It should be less than 70 but more than 50 and less than 100. It can be 60, this one can be 85, this one can be 110, this one can be 105, this one can be 120. Now it is asking for the complexity for insertion and deletion. Can we have a tree like this, 100, 90, 80, up till 10? Yes, we can have a tree like this. What will be the height of a tree? For this tree, for n nodes, it will have a height of n. Now if we want to insert 5, we will compare all the items. It is less than 100, less than 90, less than 80, less than 70, up till less than 10. So we will have n comparisons. So complexity is theta of n. Similarly, if we have a tree like 10, 20, 30, 40, 50, then its height is n. And if we want to insert 100, then we need to compare with everyone, more than 10, more than 20, more than 30, more than 40, more than 50. So 100 will come over here. So we will have n comparisons. So in worst case, we will need theta of n comparisons. So complexity for both insertion and deletion in the worst cases in case of skewed trees. So skewed trees means they are inclined towards one side, and the complexity in both cases is theta of n. So we have theta of n for both insertion and deletion in worst case. This question belongs to database management system subject and was asked in GATE CSC 2015. So the question states, a file is organized so that the ordering of data records is same as or close to the ordering of data entries in some index. Then that index is called. Okay. So let us see what is a dense index. So suppose we have a database file. So file is basically a collection of blocks. So we have some blocks. Now in these blocks we can have some entries, like this can have some entries like 10, 15, 12, 18. We can have record, and record can have a particular entry, 20, 25 and so on. Now if in an index file we have an entry for each record, so for each record we have an entry, or then this is called dense index. Okay, what is a sparse index? A sparse index is possible only on the ordered field. So these ones should be ordered. Let me write the ordered values. So ordered values can be 5, 6, 10, 15, 20, 30, 40, 50. So sparse index means for a group of blocks we will have only one entry. So suppose we have 4 blocks. So for each block we are taking only the starting entry. So we have 5, 10, 20 and 40. So this is sparse index. Now what is a clustering index? So clustering index occurs basically when indexing is applied over a non-key attribute in unordered field, in unordered manner. Okay, so what happens? Suppose we have, it should be in ordered manner, yeah. So non-key. Suppose we have file has 5 blocks like this, and each block can have 2 records. Now we have ordered entries like 4, 4, 4, 5, 5, 6, 6, 7, 7, 7. It is a non-key. Non-key means repetition is allowed, but it is ordered. So we will have entry for each unique symbol. So as for each item we have an entry, thus it is a dense also. But for each repeating entries we have only one entry. Like for each 4 we have just one entry. For 5 we have one entry. For 6 we have one entry. For 7 we have one entry. As for a group we have a single entry, thus it is sparse. But as for each item, like 4 also has entry, 5 also has entry, 6 also has entry, 7 also has entry, thus it is dense. Now the question is asking, the ordering of data records is same as or close to the ordering of data entries in some index. So answer is clustering index, because it has the ordering of data entries same as in some of the index. So answer is option C.